Hi everyone, welcome to Vedantu NEET English. I am 𝐂𝐡𝐞𝐤 your chemistry master teacher. So guys, everyone, am I audible? Am I visible to all of you or not? Firstly, let me know that in the chat box. And very happy to see already you guys are very excited for today's lecture. And it is must, right? So after completing full syllabus, as I told you, that we will also cover sessions like all naming reactions, all mechanisms, all important reagents and all exceptions of inorganic chemistry. These kind of sessions will be there, right? Okay, every week there will be one session. It totally depends on you, what's your reaction on that. Okay, if you want me to make other sessions like that, then I would like to see the Josh in the comment section, in the chat box. Yes, everybody, why it's late, as I already told you that, guys, see, I was preparing this for you, right? I was preparing this for you, this for you, this for you. So I was collecting previous year questions. I was making handwritten notes for you. So it took me, half an hour late, right? So I was preparing that way. I was like, okay, let's finish this off. Let's also include some previous year questions from the naming reactions only. Okay, so all the questions that I have picked from organic chemistry are from your naming reactions. That means what we are going to study today, right? Only the naming reactions. From that, what kind of questions are asked, that we will see, right? In your previous year, last 10 years questions, right? Okay, yes. Okay. Perfect. So, shall we start the session, everybody? Shall we start the session? Yes. Okay. Yes, everybody. Sukanya, Kritika, Sameer, Ayatian, Vinutha, Nane, Vishnu, Sneha. Yes, Roshni, very good. Green hearts, yes. 12 boards, definitely. For 12 boards, you can see up to where I am teaching the naming reactions. After that, when I'll come to the previous year question, you can skip after that, right? Because previous year questions are not useful for the students who are not preparing for NEET. Definitely, they are useful for JEE students or other competitive exam level, right? Because same kind of questions are asked everywhere. But for your board examination, concepts are same. The way of asking the question is little bit low as compared to NEET exam. Okay? Yes. Okay, then let's start the session starting with the very first naming reaction from your Diksha ma'am's name, that is Darzen reaction. So I want to see everyone's what kind of meme or what kind of mnemonic you use to learn that reaction, because all the reaction will have very weird names. Okay, so we have to make some funny trick to learn these kind of reactions, right? So I want to see your tricks as well for these reactions. So the first reaction on your screen is Darzen's reaction. Okay, Darzen reaction. Have you seen that car? Tarzan? There was a Tarzan is also a I think cartoon show, Tarzan, right? There is also Tarzan movie, right? That was a very famous movie 15 years back, right? So there used to be a car which name was Tarzan. So now let us see this Darzen reaction. From that you can remember this. Here what we actually do is we have alcohol and we add thionyl chloride. Okay, this SOCl2 is thionyl chloride. Thionyl, because they can also ask you, because student, SO2Cl2, this is sulfuryl chloride. Right? So you need to be you should know the difference between what is thionyl and what is sulfuryl chloride. This is used in Darzen reaction. And sulfuryl chloride is used in Reeds reaction. Okay, that is used in Reeds reaction. So now you need to focus on these reagents as well. What is the reactant? What is the product? So in case of Darzen reaction, the reactant we have is ROH. And in this case, the reactant that we have is RH. That means hydrocarbons or alkane are in the Reeds reaction. But in the Darzen reaction, you have alcohol. The products are completely same. That is, you have RCl, SO2 and HCl. Now, this is why this is a very useful reaction, because here vapors are formed, right? The byproducts are also vaporizable, so they can convert themselves into vapors only. So it will be very easy for us to separate this product that we wanted, right? So that is why this is a very, very useful reaction. Okay, yes. Now, next is Sabatier-Sanderson reaction. Guys, just ignore these stupid people here. Let's not, let's not get our mood bad, or let's not get, because of these stupid people, let's not spoil something that we don't want to spoil. Okay, let's focus on this thing. Okay, yes. They are brainless people, so just ignore them, right? Okay, how to ignore them? By putting your comments in the comment section, in the chat box, right? So in that way, I also won't be able to see their comments, right? Okay, yes, that was Darzen reaction. Darzen reaction and Reeds reaction are very, very similar to each other. That's why I have shown you this thing, right? In Darzen reaction, we also use pyridine here, right? Then we have Sabatier-Sanderson reaction. In Sabatier-Sanderson, this is basically a hydrogenation reaction only, right? This is nothing but a hydrogenation reaction, right? So in this hydrogenation reaction, you have alkene or alkyne. Now this alkene or alkyne is converted to alkane only with nickel as a catalyst. So if you're using nickel as a catalyst, then you have to elevate the temperature to 200 degree to 300 degree. Approximately, it is studied that with alkene, you just need 200 degree around Celsius temperature. But with alkyne, you need more temperature here, right? And here you have the formation of alkane. If you use platinum here, then you don't need elevated temperatures here. But this particular reaction is for nickel only, right? Okay, yes. Yes, students. Yes, Darzen reaction was basically you have alcohol. Alcohol OH is converted to this OH is converted to this Cl. That means alcohol is converted to alkyl halide in the presence of in the presence of thionyl chloride. Thionyl chloride is used in Darzen reaction where the reactant is ROH. But in Reeds reaction, there is little difference, right? We use sulfuryl chloride, which is SO2Cl2, and here the starting reactant is hydrocarbons, that is alkane, not alcohols. That is a very slight difference between Reeds and Darzen reaction. Okay, now the third reaction, guys, today we need to complete 60 reactions here, right? Okay, so let's focus. Okay, now the third reaction is Wurtz reaction. I'm not only going to tell you the reactions where the reaction is important, only the reaction, reactant, reagent are important. I'm going to tell you only the reactant, reagent. But where the mechanism is also important, then we will also study the mechanism in those naming reactions. Because in some naming reaction, the mechanisms are as well as important for you, right? The questions are also asked from mechanisms, right? So now let us see the Wurtz reaction. So in Wurtz reaction, basically what you have, in Wurtz reaction, you have alkyl halide, right? Now, and you are using sodium metal here in the presence of dry ether. First question that can be asked is, why you have used sodium? Sodium though you have used, but why you have used a dry ether here? What is the use of dry ether here? So why we have used ether is because this sodium, right, this sodium with this ether, suppose this is the ether, it will have the solvation energy, right? So many ether molecules will be present here and they will have the solvation energy. Because of this solvation energy will be released and it will be easy for the reaction to occur. Second thing is, why dry ether is used? Why not simple ether is used? Because in the dry ether, right, when you talk about sodium is very reactive with the moisture and the air. That's why we keep sodium in kerosene oil, right? So that's why we use dry ether. Even in Grignard reagent reactions, we use dry ether because Grignard reagent is also very reactive with the moisture or the air, right? Okay, so that is why this is used. Now that was about the reaction, that you have two alkyl halides, you have sodium. Now this will be eliminated and you will have the formation of RR. But here the mechanism is also important. Why the mechanism is important? What is the intermediate? That thing is important for you. So as you can see here, the intermediate that we have here is free radical, right? Because of this, we'll be able to answer the questions from Wurtz reaction, Wurtz-Fittig reaction or fatigue reaction. In all these cases, you have free radical as the intermediate, right? So now this is your intermediate that is formed. Why? Because of homolytic cleavage, you have the formation of free radical, and now these two free radical molecules will combine to form RR. Now, important thing is free radical is formed here. Next important thing is double the number of alkyl chain is formed here, right? And we are saying that symmetrical and even number of carbons are possible. That means propane is not possible here. Methane is definitely not possible because double the number of carbon chain is formed. And methane is only one carbon. So how can we double it? We can't use half and into multiplied by 2, right? There is no half carbon that exists, right? So that's why methane is not possible. All the other odd number are not possible. Odd number of carbon are not possible. Unsymmetrical alkane are not possible. Here only even and symmetrical alkane can be formed from this reaction, and this is called symmetrical and this. Now next important thing about this reaction is that if you use these two things, okay, with the help of examples I'll tell you. For example, they have given you these kind of reactions, okay. One, so they can give you very simple reactions, very simple reactions like this, okay. Very simple reactions they can give you like this, that you have CH3, CH2, Br. Now you need to tell us that what is formed here. So we know what is the reagent that will be formed, that is CH3, CH2. These kind of two molecules will be formed, and after that they will combine with each other to form CH3, CH2, CH2, CH3, right? It was so simple. But now if they want to ask you question of NEET level, right, a good question if they want to ask you, then what they will do? They will ask you that, okay, this is the reaction, you are doing Wurtz reaction here, what will happen in the answer? So very simple thing, right? Firstly, just remove the halogen atoms here, and from this we know that homolytic cleavage will occur here, and here you will have one electron, here also you will have one electron. So you can make something like this. This will be the double bond will present here only, and instead of this Br you will have a free radical here. Instead of this Br you will have a free radical here, right? Now two things can happen, intermolecular and intramolecular, and always intramolecular is more stable as compared to intermolecular reaction. Ma'am, what do you mean by inter and intra? Ma'am, I don't understand. So very simple thing. See, two things can happen here. So I am writing it here. What is intermolecular? Intermolecular means between two molecules. So right, you will have two molecules of this and they will combine together and they will make something like this. They will make something like this. Okay, how they will combine together? You can just form it like this. This is one free radical. This is another molecule, right? This is intermolecular. When two molecules are combining together. Now this free radical will join this free radical will join, and they will form this kind of single bond here, right? This is by intermolecular. This is by intermolecular. What about intramolecular? What about intramolecular? When within the molecule these two free radicals are combining with each other, then they will form something like this. Can you see? They will form something like this. These two free radicals will combine and they will form a bond here, right? Now, which is more stable? I am telling you that usually intra is more stable. Like, I'll do the same thing for this thing, then I'll tell you which is more stable, which is the major product. Similarly, for this I have CH2, CH2. This is my Br, this is Br, that's why there will be a free radical here, there will be a free radical here. Two things can happen here also. One is intramolecular, one is intermolecular. If I say intermolecular, there also can be intramolecular, right? With intermolecular, what can happen? Two molecules will combine together. That means this will be CH2, CH2, free radical, CH2, CH2, free radical, free radical. They will combine together like this, they will join together like this, and you will have the formation of these bonds here. Okay, you will have the formation of these bonds here, right? This butane is formed. This cyclobutane is formed in intermolecular. But with intramolecular, when they will combine together, you will have the formation of this. Now, very important thing I am telling you, that usually intramolecular is stable. So here, I will not even see intermolecular. I'll just see, okay, intramolecular. This is not, intramolecular should not be anti-aromatic, because anti-aromatic is a very unstable compound, right? If you ever see that anti-aromatic is forming, so you will just stop that reaction. Nobody on this planet wants to be anti-aromatic because it's the most unstable species, right? So you'll just see, okay, this is ethene, this is not anti-aromatic. So yes, this is the major product, right? Always just see what is intramolecular product, then see whether it is anti-aromatic or not. If it is not anti-aromatic, then definitely it is a major product. But here, as you can see, this is the intramolecular product, but this is anti-aromatic also. How? Because here plenarity is followed, complete conjugation, cyclic, yes. But how many electrons? 4n pi electrons, because it has 4 pi electrons. That means it is anti-aromatic. When something is anti-aromatic, it is very unstable. So this reaction will not occur. Rather, this reaction will be supported and this will be your major product. Okay? This is going to be the major product. Got it? Everybody in the chat box, got it or not? What is going to be our major product when you have these kind of situations, right? Okay. Ma'am, is it important to write down class notes? No, no, Vinutha, don't worry. I'll provide you the notes on Telegram channel, okay? If you write, then you will miss out to so many things here, right? Okay, because I am doing fast track revision we are doing here, right? So just listen what I am saying, okay? Just focus here, right? Okay, next is, this is your Wurtz reaction. Wurtz-Fittig and Fittig reaction are very similar to Wurtz reaction. Let us see how. See, just imagine Wurtz as alkene and Fittig as aryl. Okay, Wurtz is a normal chain and Fittig is a aromatic ring. Wherever you will see Wurtz. Now here you have seen only Wurtz. That means both will be the alkane parts. That means both will be the alkyl chains, open chains, simple chains. But when you see Wurtz-Fittig, one will be alkyl part, other will be aryl part. Everything else is going to be same. This is going to eliminate, that is minus NaX. Then you will have the combination of this R over this benzene and you will have the formation of this aromatic derivative, right? That is called Wurtz-Fittig. But when we talk about Fittig reaction, Fittig means aryl ring. So now there is no Wurtz. That means both of them will be aryl only. Okay, so now this is also your aromatic, this is also your aromatic. Now again, minus NaX will be subtracted from this side, right? This will be eliminated and you will have the formation of biphenyl or diphenyl. Okay, you will have the formation of biphenyl or diphenyl. That is your Wurtz-Fittig and Wurtz reaction. Next is soda-lime decarboxylation reaction, a very, very important reaction. Usually it is asked, frequently asked question, okay? Now, first is what will happen here, right? 2-3 things to notice here. One thing is soda-lime. Soda-lime means you have caustic soda, that is NaOH. You have lime also, that is CaO, that is quicklime. Okay, so now these are used, and also here you have the carboxylic salt, sodium salt of carboxylic acid, right? Now, Kolbe's reaction, that is Kolbe's electrolysis and soda-lime decarboxylation, they are quite similar. But But there is big difference in these two things where students get confused. Okay, so you need to see those differences here. First thing is, here definitely carbon dioxide is eliminated, everything is right. But what is the product form, that is important for you. The product formed is R, and here you will join just one H here. That means if you see the alkyl chain in that carboxylic salt, right, this is the alkyl chain, the same number of carbon will be formed as the alkyl chain. This carbon will be eliminated. This carbon will be eliminated, and this R and this H will join together, and you will have the formation of RH. But when you talk about Kolbe's electrolysis, if you talk about Kolbe's electrolysis, I will also show you the comparison here. If you talk about Kolbe's electrolysis, see the reactant is same, RCOONA. But the answer here is RR. Okay, that is the correct answer, RR. So RR means when this will be taken out, when this will be subtracted, this will be liberated, carbon dioxide is already liberated. Now, this R part will be double, right? The answer will be the double of the alkyl chain, right? So here the answer is RR. There the answer was RH. That is the difference, okay? That is the difference. Now, let us see what is the important point here. Next important point here is intermediate is carbanion. Okay, this you need to remember, because whenever they ask you about soda lime decarboxylation, if a direct question is asked, you need to remember this thing. And if a complicated question is asked, not even complicated, I would say a good level question is asked, they will ask you question related to this carbanion, right? How carbanion is formed? Let us see the mechanism here. As you can see in the mechanism, here firstly, this will be splitted into the ions, that is RCOO negative and Na positive. Now from this, the electron will jump here, this bond will jump on the R, and hence you will have the formation of R negative. This is the carbanion. That is why the stability of this reaction will depend on the carbanion stability, right? And now this R negative will combine with H positive. You will have the formation of RH, right? Okay. And hence, they can ask you the question like rate of reaction, right? They can ask you the question like what is the rate of the reaction? Okay. Ma'am, not understood major and minor product. Okay, I'll tell you after this reaction. Okay, I'll tell you after this reaction. Rate of reaction. Now, rate of reaction will depend on the intermediate. What is the intermediate that was formed here? That was the carbanion. That means rate of reaction of this particular reaction will depend on the carbanion stability. Now, I told you when we were doing GOC that carbanion means stress, right? Carbanion, carbocation means money, right? More the money, it's better. But more the stress, it's not good. So, carbanion is negative. So, whenever we talk about the stability of carbanion, if you are giving the electrons to carbanion, you are donating the electrons. That means someone is already under stress. You are giving them more stress, then what will happen? They will become very sad, no? Or they will become happy that yes, you are giving me stress, I am happy. Now, when you are taking away stress from someone, they will become stable, they will become happy. That means here we need electron withdrawing groups. We don't need electron donating group. That will tell us the stability here. So if you talk about the stability, this is A, this is B. I want to see the answers in the comment section. Now, this will be negative, positive, negative, positive. That means this is the carbanion that we are talking about. Now, as you can see here, this is going to give the electrons. This is going to take the electrons. Now, here one more important thing. One more important thing. Halogen. Halogen. Okay. Whatever I am speaking here is worth coming in exam, okay? So, halogen. Halogen is showing minus I and plus M effect. Both it is showing. But minus I effect is more dominating. Usually, mesomeric effect is dominating everywhere. But it's the only exception where Inductive effect is dominating. That is why usually students get confused that ma'am it will have lone pair, ma'am, it will donate the electron. Oh, no, 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 no. In this case, inductive effect is more dominating. So it is a deactivating group. It is a deactivating group. That is why it will take out electrons from here. Whenever someone is taking out electrons, we are giving the stress to them, then we become more happy. So B is more stable as compared to A. That is why rate of reaction in B will be more as compared to the rate of reaction in A. Okay, understood? Okay guys, first you tell me, is this thing clear? You know, now see, Vanutha was asking a previous question, but now I have jumped to the next question. That's why I'm asking that whenever you feel that, okay ma'am, we are clear on this, just tell me in the chat box. So that because I will not come again and again back to the reaction. Okay. So whenever I ask you, just let me know in the comment section that yes ma'am, we are clear on this. You please continue with the next one. Okay. Yes. Now let us see the question that Vanutha was confused about. Now let us see this. Okay. I was telling you that one question is a simple question they can ask you. Always how to solve Wurtz reaction. Firstly, make a free radical, then combine two free radical, right? Answer you will have. You make a free radical, combine two free radical, you will have the answer, right? But if you have two halogens in one reaction only, in one reactant only, now that means this will be the free radical. In this case, two possibilities we will have, intermolecular and intramolecular. Usually, intra is always stable. Intra is always the major product. Intra. Now, as I can see here, this is inter, this is intra. I am telling you that intra is always the major product. So, blindly you will just write, okay, intra is the major product, right? Okay, because we just combine these two dots together, it will have ethylene, ethene. This is the major product. But if your intra product is anti-aromatic, then this rule will break. Then it will be like, I don't want to get converted to something which is anti-aromatic. Then it will not prefer this path, rather it will prefer this path. No doubt it is preferring now inter path, but it is more happy because at least it is not getting converted to anti-aromatic compound. Okay, understood? Yes. Okay, how intra is formed? Intra is formed by this thing. When in one molecule they both combine together. This is intra. These two dots are combining together. Intra, within the molecule. These two dots, these two free radicals are combining together. Here also when these two dots will combine together, this is your intra. Okay? Understood? Okay. Now, next is this one more reaction based on the decarboxylation, soda lime decarboxylation. We can also prepare benzene from soda lime decarboxylation, right? For example, you are using this reactant. Here again, what will happen? You are using this. What will happen? CO, Na. This will be eliminated as Na2CO3. And what you will be left with here, you will have the addition of hydrogen and you will have the formation of benzene here. So benzene can also be formed by soda lime decarboxylation reaction. Okay. Next we have Kolbe's electrolysis. Now, as I was telling you that in Kolbe's electrolysis, this is this is quite similar to soda lime decarboxylation, but things are very different here. And don't get confused between Kolbe's reaction and Kolbe's electrolysis. Kolbe's reaction is a reaction of phenol. This is Kolbe's electrolysis. They both have no relation with each other except for the scientist. Okay. Now, Kolbe's electrolysis, we are using the same, that is sodium salt of carboxylic acid. Now, here we are doing the electrolysis. Whenever there is electrolysis, what you have? At anode, at cathode. We know that at anode, there is loss of electron. At cathode, there is gain of electron. So, can I write here? Here you have loss of electron. Here you will have a gain of electron. Now, When you are losing that electron, what will happen here? Right? This is the CO, this is your anion. It is going to lose the electron. What will happen here? The electron will shift to this side and one electron will be subtracted, will be taken out from this O negative. Right? Now this oxygen will be left with only one O negative. Now ma'am, do I need to remember the full mechanism? No. Right? You just need to remember few things here. That is, this is a free radical mechanism. Okay. First thing to remember here is, this is a free radical mechanism and the questions will be same as Wurtz reaction only. Right? So this is a free radical. Soda lime decarboxylation, the intermediate is carbanion. Here the intermediate is free radical. Right? Okay, that is why we have the formation of RR. Because here R free radical and R free radical will combine together. Right? Next important thing to remember here, that at anode you have the formation of carbon dioxide. Right? Because what will happen once you have this free radical, again homolytic cleavage will occur here. Right? And here you will have the formation of R free radical. When this will go to this side, you will have the formation of C double bond O free radical and this free radical. Now these two free radical will combine together. It will be a situation like this. Okay, it will be a situation like this, that you have C double bond O, free radical here, free radical here. They will combine together to form carbon dioxide molecule, and hence carbon dioxide will be eliminated at anode. Right? This they can ask you, which is eliminated at anode. What they can ask you, what is the intermediate? That is free radical. At cathode there is gain of electron, and hence here you will have the formation of H free radical. How it will be formed? Basically you will have this thing. Right? Okay, here you are gaining the electron. So what will happen? It will gain the electron, and firstly so this will happen, this will break, and you will have the formation of OH free radical, H free radical. When this will gain the electron, it will become OH2 free radical. So it will become a negative here. That is why you have OH negative and H free radical. Right? Now, once you have OH negative, H free radical, this OH negative and the Na positive here, they will combine together to form this. That is why we will say it is a basic medium. After the reaction, the medium will become basic in nature. Second question that can be asked, this is at anode, this is at cathode, this is at anode, this is at anode. Okay, this can be asked to you. Okay guys, got it? What can be asked? Free radical mechanism. Next is what is at anode, what is at cathode, this can be asked to you. Right? Now, related to free radical mechanism, what kind of questions can they ask? Right? Firstly, let me show you what kind of question. Now, this is the question they have given. They are saying that you are doing Kolbe's electrolysis, you are adding water, you are doing electrolysis. By this, you should be clear that, okay, if COONE is given and there is electrolysis, that means this is a question of Kolbe's electrolysis. You need to see the reagents as well. Now, what you do, just eliminate this thing from here. What you will get a free radical like this. Okay, firstly make a free radical like this and you will have the formation of this free radical. This is the free radical that is formed. Now, this free radical will combine with the same molecule, right? Okay, they two will combine together and they will join together and they will make a single bond here, right? Which will look something like this. This is the answer that you will have. This is the alkane that will be formed in this case. Got it? Firstly, in Kolbe's electrolysis, you will make the free radical. Then two molecules will join together. Then you will get the answer. It is same as Wurtz reaction, same. Okay. Now, with the same reaction, with the same reactant, if they have given you NaOH, CaO, can you tell me what will be the answer? If the same reactant is given, but the answer will be different here. This is soda lime decarboxylation. What will be the answer here? CH3 will remain as it is. Here carbanion is the intermediate. This will be removed. Instead of this, you will have hydrogen here. That means this thing. Or hydrogen, so we don't even need to mention. So this will be the answer. Okay? This will be the answer. This will be the answer for soda lime decarboxylation. Okay, yes, 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 yes. Varuta, let's focus on one thing today, okay? That is naming reaction. Now, next question is Reeds reaction. As I have already told you, this is similar to Darzen. Here we are using alkane as the starting product, right? You will get alkyl halide from here, sorry, alkyl chloride here, right? What is different? Here you are using sulfuryl chloride. Sulfuryl chloride you are using, okay? Not thionyl chloride. Answer is same, that is RCl, SO2 and HCl, they are formed. The answer is same, but the reactant is different, the reagent is different, okay? Understood? This is called Reeds reaction. Next is Lindlar's catalyst, okay? Now, Lindlar's catalyst, that is basically poisoned by sulfur, poisoned by quinoline, poisoned by CaCO3, right? Or simply they will write BaSO4, right? This will be BaSO4, right? Okay. So anything they can ask you, or simply they can write poisoned by sulfur. So basically what happens here, we know that whenever we have this alkyne, okay, we are doing the hydrogenation. Now, hydrogenation is a catalytic process. So, it will be like, I to want to convert this into alkane. I will convert this into alkane. You are like, we don't want to convert this into alkane. We just want to stop to the alkene process. That is why a poison is used. And that poison is called this PbSO4, BaSO4, quinoline, sulfur, CaCO3. Usually they can write just simply poisoned by sulfur so that the reaction can stop at alkene point. Now, next two questions that can be asked from here. One is cis alkene, one is trans alkene. So cis alkene, this question is a very frequently asked question in your NEET exams, that cis alkene is formed where and trans alkene is formed where. Now, when you are using Lindlar's catalyst, doing the catalytic hydrogenation, in that case, you will have the formation of cis alkene, right? But when you are doing the Birch reduction, in Birch reduction, the answer is different, right? In Birch reduction, the answer is not cis alkene, the answer is trans alkene is formed. That means RR will be on the opposite sign, right? Now, what is the reagent of Birch reduction? Either you can use sodium or lithium in presence of liquid ammonia. That you will have the formation of trans alkene here, right? Trans alkene will be formed here. Now, guys, let us see this very important thing here, that I told you about the Kolbe's electrolysis, right? But in Kolbe's electrolysis, and this I will tell you also in Birch reduction, okay? So there are some things that are not usually mentioned in NCERT, but that are very important for you to note down, right? That is why I have taken up this lecture, so that what is not there in NCERT, you can also cover those things, right? Okay. So now, let us see this thing here. We know that simple reaction is when you have Kolbe's electrolysis, this will be double. That means a bond will be formed between these two and you will have the formation of RR. But what if already you have dicarboxylic acid, right? Okay, this may be CONA or maybe COH, whatever is given to you. Now what will happen? You will have the formation of alkene. This will be eliminated, right? And here you will have the formation of a bond. This bond will be formed here. Same thing we are doing, guys. Same thing we are doing. Here also, you have eliminated this. You had R and you had the formation of a bond with hydrogen, right? Now, oh, sorry, not with hydrogen. This is with R. 2R you have R and this R. They will make a bond and you will have the formation of RR. This you have done here. Here also what will happen? You will have the formation of a free radical here, a free radical here. They will make a bond here and a double bond will be created here. That means alkene will be formed from Kolbe electrolysis if you have dicarboxylic salt, right? But in that you also have single bond there. Now, if you have dicarboxylic salt, but you already have a double bond. Again, what will happen? There will be a free radical here, they will join, and you will have the formation of this alkyne. This will be eliminated. This will be eliminated. Got it? So this is how you form alkyne. Okay? Yes. I think you guys are studying this for the first time or what? Now, okay, I'll show you that again. Guys, see this thing. What I am telling you, that you have R free radical, R free radical. They will combine together to have the formation of R. Okay? This is what we do in Kolbe's electrolysis, isn't it? This is what we do. R free radical combine together, they have the formation of R. We are making a single bond there, right? Now, same thing we will do here. Here also we have eliminated this. We have put R dot here, one more R dot, they combine together to form RR. Firstly, tell me, is this thing clear or not? After this, here also I am doing the same thing. You are eliminating these two COONA or COH groups, right? After this, what you did here? You had the formation of this dot here. Same. Here also this free radical will be formed here. Then they will combine together and you will have the formation of this thing, right? You will have the formation of this alkene, right? Here also I am doing the same thing. This will be eliminated. Here you have one free radical. They will combine. You will have the formation of this alkyne. This is how from Kolbe electrolysis you can have the formation of alkene and alkyne as well. Okay, clear? Yes, everybody, clear? Yes. Now, let us see the next thing. Reed's reaction we have done. Lindlar's catalyst also done. Birch reduction. We were at Birch reduction. In Lindlar's catalyst, cis alkene. In Birch reduction, trans alkene is formed. Right? Now, what other kind of Birch reduction can be there? Right? Little bit good level of question. Okay, just see this. Very relaxed. I'll explain you what exactly we are doing here. Right? That is why this lecture is very important. Right? Because I have collected like full material that is required for you. Right? You don't need to do anything apart from what I am doing today. Right? Okay? So everything you will see, it's not okay, my students should feel this is easy. Easy to air, everybody can do. Right? You should also know these concepts. Right? What's the bad thing? You guys are like, okay, ma'am is doing something difficult, I'll just go and end this class. This is what you are actually lying to yourself only. If someone is teaching you something that is taught in offline, I'm teaching you that thing on YouTube, you should be grateful for that, okay? And try to understand that, right? Okay. Now, let us see the Birch reduction here. Birch reduction, simple, you have seen here that alkyne is converted to trans alkene. Done. Now, if they are going to make NEET 2025 paper difficult, right, then what they will do, right? Okay. Yes. Now, bit of Birch reduction is in your syllabus. Okay, don't worry. That is in your syllabus, right? So now let us see this. If they will make a good level of question, this is very simple, okay? Just go through this. Very simple. I to first have to convince you, right? Okay. Now, Varisht in JEE, so there is more, like in JEE, not mains, in JEE advanced, there is more, right? Okay, it is not limited to this only, what I'll do today, right? This is for NEET, strictly for NEET, right? And maybe JEE mains, but not for JEE advanced, right? Now, Birch reduction, see this. You have benzene, right? Here you have Na, NH3, everything is same. See, what will happen? Just remember the answer here. Benzene, one bond will break and you will have on the opposite positions, you will have the double bond, right? On the opposite positions, you will have the double bond. Just remember the answer here. In Birch reduction of benzene or its derivatives, in Birch reduction of benzene or its derivative, answer will be 2 pi bonds. Answer will be 2 pi bonds, right? Now, if you are simply using a simple benzene, then these two double bonds will be opposite to each other. This is the correct answer. Now, if they have given you any electron donating group like this, Now, donating. Acha, tell me one thing. Who is donating something to you? You will be very close to them, right? If someone is donating something to you, donating their notes to you, making notes for you, right? Or giving you previous year questions, you will be close to them or you will stay away from them. You'll close to them, right? Because they are helping you. If someone is donating, they are a good person, right? So with the donating, you should be close to them. So these double bonds will be opposite only, but they will be close. Close means this will be next to the double bond, will be next to the electron donating group. That means if I make the answer here, the answer will be, this is CH3. I need to make double bond on the opposite positions, right? So here it will be close. Either I can make this thing or I can make this thing. Both are the correct answer. Either I can make this thing, because after CH3, this is the only double bond that benzene can have. So opposite to this is this one, right? Or I can make this double bond and this double bond. Okay, understood? Now, if they are giving you electron withdrawing group like NO2, if they are giving you electron withdrawing group like NO2, now they have given you NO2. Now you will be like, what to do, ma'am? NO2 they have given, ma'am, should I do the same? Now if someone is taking out money from you, right? You are like, okay, this is my saving. You went to your coaching or maybe school in your friends group. You said that, okay, I have bought this thing. They're like, okay, give us this thing. They just snatched everything from you, right? So they have withdrawn everything from you. If someone is withdrawing something from you, you will stay away from them or not? I too will stay away from someone who is stealing everything from me, right? So when someone is withdrawing something from you, you will stay one step away from them. So I'll be one step away from them. Again, double bond will be opposite only. Tell me, is this difficult? Is this easy? Is this difficult or is this easy? Easy, no. Very simple. One bond we will break. Other two bonds will always be opposite to each other. In simple, though, we can make anything. You can make this thing. Even this is the correct answer. Even this is the correct answer. All of them are the correct answer. All of them are the correct answer. All of them are the correct answer only. Because the double bond should be opposite, right? All of them are opposite, simple, right? Now, donating double bond, the condition is double bond should be next to them. So, it is next to them. Either this or this can be the answer, right? And here, double bond should be away. So, here away is this one. This is the only position that where it is away from them, right? Okay, simple. So, this is also Birch reduction. Okay, this is also a Birch reduction because you have Birch reduction in your syllabus. So, my idea was, what if they, like, you know, we know that in NEET 2024 what happened. So, let's not take risk. Okay, these things are for those students. See, if you are aiming for maybe 600 marks, maybe 550 marks, 520 marks, I'll be very clear with you. If you are aiming for maybe 520, 600 marks, then you don't need to do this thing. Okay, then why to take, then just ignore this thing, right? But if you are aiming for 700 plus marks, you're aiming for 680 plus marks, right? Then guys, you need to do even these things. Then you can't skip these things, okay? Right? Okay? Yes. Very good. Very good. I'm so happy you're aiming for 720 marks. Then to you can't leave anything, okay? Then to everything is easy for you. Everything should be easy for you, right? Now, next question is, next reaction is Wittig reaction, okay? Wittig reaction. This is also, I would fall, okay, I am making some, I am making a mark here. The mark is R, the mark is red. In red where I have written decay, you can even skip these reactions. If you don't want, if you are okay with taking risk, then you can skip this reaction as well. you can skip this reaction as well if you're okay with taking risk. If you don't want to take risk, then you must do this reaction, okay? Yes. Now, here again very simple. Here you have phosphorus yellide. What is very simple? Yeah, very simple. You don't need to see in any mechanism, nothing here. Just remember the reactants and the product that is formed, okay? So this is Wittig reaction. In Wittig reaction, what we do? This is phosphorus yellide. Phosphorus yellide is, on phosphorus you have 3 phenyl groups and you have CH2 negative here. Because phosphorus is not able to complete the 5 bonds, that's why it is very poor. It's in like garibi, poor, so positive. CH2 is having negative because see, 3 bonds it has completed, it needs 2 more electrons to complete its octet, so that is why it is CH2 negative. Now simple thing will happen here. What will happen? They will just exchange their positions. This double bond will be shifted to this side, that is double bond O. Everything else is same. Everything else is same. Double bond O is shifted to this side, right? And here one double bond will stay as it is and this CH2 will be shifted to this side. That means it will be something like this. Here you will have CH2 and here you will have double bond O. Okay, this will be eliminated. This is the answer. Okay, and this is the formation of alkene. Okay. 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 Understood? Understood, guys? Understood, everybody? Got it? So this is called Wittig reaction. Right? Now, next is hydration of alkene, and this reaction is very important. Right? It is, I would say, the most predictable question of your NEET 2025. Most predictable. Reason being, here they will ask you these 3 things. Tricks I have written here, right? Reagents I have written here, right? In all these cases, we will add we will have a double bond, right? We will, for example, we have a double bond like this. To one we will add OH, to the other we will add H. Okay, to the other we will add H. This is the hydration of alkene. But how the hydration will happen, that is a question. Okay, so how the hydration will happen? The first is acidic hydration. If you talk about acidic hydration, that means you will add water in acidic conditions. Right? Now see, understand guys, very simple. Here, don't use, ma'am, I will apply directly Markov-Nikov rule. You will get the wrong answer here. Right? Sometimes you can get the wrong answer because sometimes actual mechanism is, in the reality, the mechanism is that carbocation is formed. After that, rearrangement can happen. After that, you have the attachment of OH negative on the carbocation carbon, right? And in the third, that is oxymercuration, demercuration, directly you will apply Markov-Nikov rule because here you have no carbocation formation, right? In the mechanism, there is no carbocation formation. That is why there is no carbocation, no rearrangement in this case. But here you have rearrangement also if possible. Okay, rearrangement if possible. You can write if possible. If possible. If it is giving more stability, only then you will have the rearrangement. Okay, now what is acidic hydration? You have water H positive. For hydroboration oxidation, what you will have? BH3, that is diborane, right? Then you will have THF, right? Then you will have H2O2, peroxide and NaOH. These are the reagents that you will see, right? Then oxymercuration, demercuration, you will have diacetate, mercuric diacetate, then you will have H2O, then you will have, see, oxymercuration. In oxymercuration step, you will use these things, right? When you are adding the mercury into the reaction, right? In demercuration, you will take away the mercury by adding NaBH4, which is a good reducing agent, right? So these are the reagents, these are the rules, okay? These are the rules. Got it? Okay? Okay guys, we will also do questions based on this when we will do previous year questions, okay? Now, next in Stidens reaction, So in Stidens reaction, what you will use? You will use NOCl, right? Now break this double bond. Cl will be attached here, NO will be attached here, and there we will have a single bond. Simple reaction. Tidden's reaction, what will happen? Break this bond, Cl is attached here, NO is attached here on the opposite positions. That is called Tidden's reaction. Okay, yes. Next is Bayer's reagent, right? Very important question, right? Now in Bayer's reagent, you use cold dilute KMNO4, which is 1%. Diluted means only 1% cold diluted KMNO4 you will use. Potassium permanganate is pink in color, right? So how this is a test? Because why we are calling it as a test? Because this pink color of KMNO4 will be decolorized after reaction. That is why this is a test for unsaturation. If you have an alkene and you want to test the alkene, then what you will do here, right? There are so many methods, and one of the method is this oxidation, right? We are using cold dilute KMNO4, pink color will decolorize, right? And you will have the formation, this double bond will break and you will have the formation of OH over here, right? Okay, so basically vicinal diol will be formed. You can even write it. You know what is vicinal? Vicinal means when on the adjacent position you have that group. So diol means on the adjacent position you have OH groups. That is called vicinal diol. Now one more thing that is observed, that brown color PPT precipitates of MnO2 and glycol are also formed here. Right, brown color precipitates are formed here, but this pink color will be decolorized. Okay, that will be decolorized. Now, next is Wacker's process. In Wacker's process, again, these are the reaction of alkenes, different name reactions we have. This pi bond will break, and here you will have the addition of CHO group. Okay, addition means this will be converted into CHO group, and here one hydrogen will be added. This kind of thing. Okay, so this is your CH2 double bond CHO. What will happen? This pi bond will break. Okay, there will be addition of one CH3, one hydrogen here, and here this will be converted to CHO. This is your Wacker's process. Okay, this is called Wacker's process. Okay, guys, this is called Wacker's process. Here, these kind of Tiddens, Wackers, you just need to know the reaction reagent product. That's it. Okay, if they ask you, they will ask you directly the reaction, not detail of this. Right? Now, next is Groove's process. Basically, it is famous by Lucas reagent. Right? So, what we do here, ROH, right? That is, it is basically the test for, distinguished test for 1 degree, 2 degree and 3 degree alcohols. Right? So what will happen? You will use anhydrous ZnCl2 and HCl here. Right? This OH will be converted to Cl. Right? And here, important thing that they ask you in the exam is how to distinguish. So with 3 degree alcohol, the turbidity or the cloudiness, the turbidity is formed immediately. Right? When the cloudiness or the turbidity is formed immediately, you will say, yes ma'am, this is a 3 degree alcohol. Now, if the turbidity is formed after maybe 2-3 minutes, right? Turbidity after 2-3 minutes, turbidity after 2-3 minutes or maybe 5 minutes you can write, then this is called 2 degree alcohol, secondary alcohol. For 1 degree, turbidity on heating, first thing is without heating it will not be formed. On heating, on prolonged heating, it will be formed after what time? After maybe 30 minutes, maybe it will take, even after prolonged heating, it will take 30 minutes to form the cloudiness here, right? The turbidity here, right? Okay, so this is how you will distinguish this, right? Okay, this is how you will distinguish the 1 degree, 2 degree, 3 degree alcohol on the basis of Lucas reagent. Next we have Finkelstein reaction, right? So Finkelstein reaction, right? Finkelstein, just remember this, there was a guy called Finn, and Finn was, this is Roxa, right? And this Finn was like asking this Roxa, because usually students get confused in Finkelstein and Schwarz reaction. So there is a trick to remember that, right? Because these questions are asked, right? You have Rx, you have NAI, right? There will be displacement, that means they will replace each other. R will be having this I, right? And you will have the formation of Ri, and this Na and X will form a compound, that is NaX, and this will be precipitated in dry acetone, right? So this is a dry acetone that we are using, and NaI, sorry, not NaI, NaCl or NaBr. One more thing to write down here. This X can be fluorine, chlorine or bromine. This cannot be fluorine. Okay, so either it can be chlorine or it will be bromine, right? Now, as you can see here, what will happen? This Rx and this NaI, right? You can just remember this by this thing, that Finn was a guy, right? This was the Roxa. Finn was asking Roxa to apply acetone. Acetone is basically nail paint, right? To apply acetone. But Roxa was always saying no, 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 no. Okay, Roxa was always saying no, 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 no. Right? Now, Swati asked Roxa to apply, to do some fashion in life, Then Roxa agreed to her. Okay, Roxa agreed to her. Okay, Roxa agreed to Swati. Right? Now, when Roxa agreed to Swati, basically these are your inorganic fluorides that it can use. Inorganic fluorides can be used here. Okay, inorganic fluorides can be used here, and you will have the formation of RF here. Okay, RF can be formed here after this, because this is very difficult to form. That's why we have a reaction for this, that is Schwarz reaction. These two reactions are your halogen exchange reaction, where you are exchanging the halogen. This is chlorine and bromine. This is also X can be chlorine or bromine, right? Both of them are SN2 mechanisms only, right? Okay. Next, Williamson synthesis, very important, right? From here also frequently they have asked questions in NEET, right? So let us see what is this reaction and what is the highlighted point of this reaction, right? So this is Rx, this is NaOR dash, right? So now what will happen? This X and this Na will be eliminated as NaX, right? And you will have the formation of ROR dash. That means ether will be formed, right? So this is called Williamson synthesis, right? Okay, Williamson synthesis. Now there was a son of William, right? Roxa was interested in William, right? So that's why Roxa left Finn and Swati also, right? And Roxa made with the R-O-N-A, right? Now it has converted to ether. Now they are married and they have converted to ether. Hai na? Roxa left X also. She's like, I don't want this X in my life. I don't want any halogen in my life, right? And this R-O-N-A, he left this sodium. Like, I don't want sodium in my life, right? And they both got married and this is now ether, right? Okay. Now, see one thing here, that very important thing, this point. From again, this point also is very important. Reason being that alkyl halide should be primary always. Okay, alkyl halide cannot be secondary. Alkyl halide cannot be tertiary. For example, they are asking that you have to make this halide. Okay, you have to make this halide, this ether. For example, they are asking you that you have to make this ether from Williamson synthesis. What will be the reactant? Now I know that what can be the reactant. One alkyl halide should have X, one alkyl halide should have ONA, right? Now I know that alkyl halide cannot be tertiary. So that is why this alkyl group will have X and this alkyl group will have Na, and hence you will have CCH3, because this alkoxide ion can be secondary or tertiary, but that should always be, halide should always be primary. So this is the only possibility that we will have. This is the only possibility that we will have, right? And this will be the answer. These kind of questions are asked to you. Okay, yes. Most welcome, Sneha, most welcome, right? Okay, so these are the important questions. You can see this in your previous year questions as well. This is what they ask you, right? Okay, now next is, this was 17th, no, 18th is Frankland, right? Frankland, we have done 17 reactions here, right? Next is Frankland. Frank is very frank in life. Okay, so who are very frank in life? Okay, who are very frank in life? Tell me, who are very frank? These German people are very frank in life, right? Okay, we Indians are not very frank, but in Europe, everyone is very frank. So this jing, you just remember, you can also remember that there is Frankfurt in Germany, right? If you don't have that much knowledge of geography, then you can just remember who are very frank. These Europeans are very frank, and Germany is in Europe only, right? So ZN, that is Germany. By this you can remember things. Okay, if you have any other trick, you can always remember that, right? So Frankland is same as Wurtz reaction only. Right, here also you have alkyl halide Zn, and this will be eliminated, and you will have the formation of RR. And this Frankland reaction is also not for unsymmetrical alkenes. That's why it's not very famous. Wurtz reaction is more famous, and mostly they ask questions from Wurtz reaction, right? That's why it's not very famous. But there is one reaction just like this which is very famous. That is 𝐂𝐤 synthesis. Now what happened in this 𝐂𝐤 synthesis? That we were able to make unsymmetrical alkenes as well. Unsymmetrical and symmetrical alkenes. And symmetrical alkenes, both we were able to make. Now when we are able to make both the alkenes, unsymmetrical alkenes, that means we are now successful here, right? So here they can ask you one thing, that what is the reagent that you have used? This is R2CuLi. This is called Gilman's reagent. This is called Gilman's reagent. These are organometallic compounds, okay? Gilman's reagent. This they can ask you. Now, ma'am, do I need to remember this formation of Gilman's reagent? This I have just written here, but you don't need to remember this here. I have written here that if student wants to remember, they can remember, but there is no chance that they will ask you this thing, right? Okay, zero chance that they will ask you this thing, the formation of Gilman's. Yes, they can ask you what is required in Gilman's reagent. You should get an idea that some R, Li, Rx, from this you had the formation of R2CuLi, okay? Right, important thing about this reaction is it is also applicable to prepare unsymmetrical alkenes, right? Okay, then there is diazotization reaction, right? In diazotization reaction, what you have, right? You are forming from aniline, we are preparing disonium salt, right? Disonium salt we are preparing, disonium chloride, right? Now here the reagents are very important. Firstly, they can give you NaNO2 and HCl. When they will combine together, they will form HNO2. So either they can give you directly HNO2, don't get confused here. Either they will give you directly HNO2 or they will give you NaNO2 plus HCl. Right? Don't get confused. Sometimes they give you this thing, sometimes they give you this thing. This is the same thing only. Temperature is important because this disonium salt is stable in cold condition, that is 0 to 5 degrees Celsius. So this much temperature is required here. More than that, this disonium salt will liberate nitrogen. So that is not required there. Right? Okay. Then why I showed you this reaction, this is not a naming reaction as such. We have seen weird names everywhere. This is not a weird name, right? This is just like a normal name. Why I have told you this here? Because from this compound, there are so many naming reactions associated with this one. That's why. Now, first naming reaction is Sand-Meier's reaction. Sand-Meier, remember, sand means salt. Okay, because Sand-Meier and Gattermann reaction are quite similar, exactly similar. Reactant are same, product are same. But the reagent is different, and there is a very slight difference in the reagent. In Sand-Meier, you use salt. Salt means salt of copper with chloride or copper with bromide. If you have chloride here, you will have the formation of chlorobenzene, right? If you have bromide here, you will have the formation of bromobenzene. If you have not chloride, not bromide, you have CuCN, you will have the attachment of CN group here. That is, nitrile group will be attached on this position. Okay, nitrile group will be attached here, right? Okay, now these are your Sand-Meier reaction. Gattermann reaction is similar, but in this case, Gattermann. Okay, so in Gattermann reaction, we know Gatter is like gutter. Okay, gutter is like gutter. So whenever you pass by some gutter is a very dirty place. Okay, so whenever you pass by some gutter, what you will try to smell some powder, good smell you want to have, right? So here we are using copper powder. Instead of salt, we are using copper powder here. So this is the copper powder we are using, and here what you will have the formation of, again the answer is same, right? Chloro and bromobenzene. Ma'am, can I also prepare one important question that can be asked to you? Can you prepare cyanobenzene from Gattermann reaction? No. This cannot be prepared. Just write it here. This cannot be prepared. Not from Gattermann reaction. This cannot be prepared from Gattermann reaction. Okay, this cannot be prepared from Gattermann reaction. Okay, understood? Next, Balz-Schiemann reaction. Okay, now tell me, whenever we want to have good hair, right, what we are doing with good hair, what I am doing, okay, if I just apply oil on my head, right, I come like this, you will say, ma'am is not fashionable, है ना? When I'll come with very good hairstyle. Now to my hair are not in a good hairstyle condition, but when you see someone with very good hairstyle, you will say they have fashion sense, right? So here Balz-Schiemann. So here she is doing the fashion. She means female is doing the fashion. She is like, okay, I want to take care of my hair, I want to have this kind of hair, that kind of hair, right? So now you will have fashion here. Fashion means fluorine here, right? So this is your HBF4, and here you are going to heat it and you are going to have fluorobenzene. Okay, this is called Balz-Schiemann reaction. Acha, one important thing here. Usually students get confused in this. If you add HBF4, then you add NaNO2 with copper couple, then you heat it. Now the answer is entirely different. Though this is not a naming reaction. This is not a naming reaction, what I am telling you here. Because this is quite similar. That's why I am just writing this here. This is nitrobenzene is formed. This is not Balz-Schiemann. This is not Balz-Schiemann. Not Balz-Schiemann reaction. Okay. This is not Balz-Schiemann reaction. But this question also can be asked to you. Right? Okay? Understood? Right? This is Balz-Schiemann. This is not Balz-Schiemann. But one step ahead, we can form nitrobenzene as well. Right? From the same thing. Super tricks? Yes. Okay. Now, Hundsdecker is very funny trick again we have. Right? So, you remember Swati? Now we have Swati's mother. Okay? Now she is Swati's mother. We know that moms are a little bit fatty, right? So Swati's mother is little bit golumolu, right? So now this is our Swati's mother. Swati's mother is wearing that silver chain because we to don't like, I am not wearing anything, you know, any silver chain, any accessory I am not wearing. But my mom is always wearing some good silver or good accessory, gold accessory, right? Our moms are always wearing those kind of things, right? You will always see. Now, Swati's mother is wearing this silver ring or chain. Just remember chain. Now, there are bad criminals. Those who understand Hindi, bure chor, those who understand only English, bad criminals. Okay? Okay? So, it depends on which language you are more comfortable in. Right? So, now, bad criminals we have. Right? Now, what will happen? These bad criminals will take the silver chain from the mother, right? And the mom will be like, oh my God, what just happened with me? Mom will like very much, she will get very anxious. That's why what will happen? She will take a big deep breath, right? So that's why carbon dioxide will be released here, right? And those bad people will take away the chain from the mother, right? Now, you are left with, the mother is only left with the bad memories. Okay, mother is only left with bad memories now. Okay, mother is left with bad memories. Mother is like, this happened, that happened. Swati is also sad because of that. Okay, understood? So this is Hunz-Decker reaction. Okay, this is called Hunz-Decker reaction. Any other language? No. Okay. So this is called Hunz-Decker reaction. Okay. Again, next is Dow's process. Dow's process, again, very important process, right? Here we should also know the little bit of the mechanism as well, right? So in Dow's process, you have chlorobenzene. First question that they can ask you is, why this is so difficult to break? Why this is so difficult to break? Why you need 623 Kelvin temperature? Why you need 300 atmospheric? Why such drastic conditions you need? Why? Tell me the answer, right? So here we are saying, bro, we are doing this because this chlorobenzene is having these lone pairs, right? That's why it is going to donate the lone pair, right? That is why there will be a partial double bond character over here. In the resonating structures, you will have the partial double bond character, and that is the reason what we have to do. That is the reason this bond is having partial double bond. It is very difficult to break this, right? First reason is partial double bond. Partial double bond. Acha, tell me second reason. Second reason is, we know that if it has a partial double bond, it has 1, 2, 3 sigma, it is sp2, right? If you talk about a simple alkyl chain, it is having sp3. If you have this kind of compound, it is easy to break this CCl bond here, right? Or if you want to see more clarity, CCl, this is H3, this is sp3 hybridized. It is easier to break this bond here, right? So sp2 is difficult to break. Reason being, sp2 is more electronegative, right? So that is why sp2 is difficult to break as compared to sp3, right? Because electronegativity is more. Third is phenylcation. I am saying even if you say that it will lose Cl negative, it will form a compound like this. Now this phenylcation is not at all stable, right? Phenylcation is not stable. Phenylcation is not stable. So that means definitely any carbocation is not formed here in the Dow's process, right? Okay. So these are the three reasons. Firstly, they can ask you one assertion, reasoning or statement based question on this part of the Dow's process. Second question that they can ask you is the intermediate. They have not asked it yet, right? Okay, it has never been asked, but still just go through this mechanism once, right? So that if they ask you, then you should know. Okay, so firstly, I'll tell you that benzene is formed here. Okay, benzene is the intermediate that you should know, because they have also asked the intermediate of Reimer-Tiemer reaction, carbylamine reaction. So it will not be a shock that if they ask you a intermediate of Dow's process, right? Because it's a very unique intermediate it is having, right? So they can just directly ask you maybe 1 second. If you have studied it, it will take you just nanoseconds to answer this, right? Now, you have chlorobenzene. Firstly, you have added base here. What is the work of a base? Base wants to abstract the proton. It wants to accept the proton. So it will take out the proton here and the electrons will jump over here. Okay, there will be 2 electrons that will jump over here. This part will jump here and hence you will have the formation of this benzene intermediate. Okay, this is how first thing is benzene intermediate is formed. After that, when benzene intermediate is formed, see, here this OH negative is acting as a base. But here this OH negative is not acting as a base. Now this is acting as a nucleophile. Now this is acting as a nucleophile. Okay, here it was trying to take out the H positive. Now here it is not trying to take out the H positive. It is acting as a nucleophile. It will attack on this, right? The electrons will be, firstly the electrons will be shifted here, right? There it will create a deficiency of electron over here. There will be deficiency of electrons over here. So it will attack here and hence you will have the formation of OH here, right? Okay. Till here we have the formation of OH, but what to do with this negative charge here, right? This we need to see, right? So what will happen here, very, very important step. What will happen here? This H will be internally transferred to this negative. This is H positive, this is negative. This will be internally transferred here and here you will have the attachment of this H. These electrons will jump to this O and you will have O negative here. Now you will add Na positive. Now everything is simple. Na positive, this is ONA, then add H positive, you will have H positive here, then phenol is formed. Okay, understood? That is the full mechanism. But ma'am, do I need to remember the full mechanism? Definitely you need to go through the full mechanism. It's not like you can get completely blank here. But what is important for you to remember that this benzene intermediate is formed. You never know, with these important mechanism they can ask you the question. So you should know that. Okay, understood? Now one more question that can be asked based on this is, okay, that can be asked on based on this is, when you have chlorobenzene and you are attaching any electron withdrawing group on the ortho and para position, electron withdrawing group like NO2, right? Now it will help it will decrease the drastic condition. It will decrease the drastic condition. The temperature, the pressure you need less. Even if you have on all the sides on ortho and para positions, you have electron withdrawing group, you just need to warm it. You just need to warm it, add water and you will get the phenol. Right? Okay. But if you are doing the same thing, but here the electron withdrawing group is at the meta position. Electron withdrawing group, this question they can ask you, okay? Electron withdrawing group is at the meta position. There is no effect on condition. But here, drastic conditions are not required now. Okay? Got it? Okay? Yes, everybody? Yes, everybody? Hanji. Now, that is done. Next is Ullmann's reaction. Right? In Ullmann's reaction, what we do? Now, it is quite similar to Wurtz reaction, right? So, or you can say quite similar to Fittig reaction. But here instead of sodium, you are using copper. And instead of any alkyl halide, you are using iodine here, right? Now, this will be eliminated. This thing will be eliminated and you will have the formation of diphenyl here. Okay, diphenyl will be formed. That is called Ullmann's reaction. Next is Cumene's process. Again, very, very important process. Very, very important. Very, you will just pick out last 5 years question. Every year, this is like mostly every year this is asked. Okay, now Cumene process. Cumene process is basically the formation of phenol, right? But here what you will have? See, first thing is you will have isopropyl benzene. This is called cumene. This is called isopropyl benzene. Okay, benzene. This is the common name is cumene. Now in this cumene, when it is reacting in air, right, basically oxidation is happening, it will have the peroxide linkage over here, not COOH, no. This is COOH. Peroxide linkage you will see here, right? So this is COH peroxide linkage, it has been added here. After this, what will happen when you add water with acidic, with H positive here in the acidic condition? This thing will be eliminated as acetone, and here you will have the formation of phenol plus acetone. That is why both the byproduct are important here, that one is phenol, other is acetone that is formed in this case. Okay, phenol and acetone is formed in this case, right? Okay. Kolbe's reaction. Okay, see, the students have left. This is the patience. Okay, this is, I sometimes feel that students want to get into AIMS, but they don't have the patience to study. Hana? You'll see after just 1.5 hours, they are like, okay, I don't want to study. That's it. That's it for today, ma'am. That's it. Ma'am, okay, no worries, ma'am. You teach good reactions. You teach like everything, but we will not watch. Reason? Because they are so tired. I sometimes feel pity. Why? Because, yeah, who is showing you these dreams then? Huh? Who is showing you these big dreams? That, okay, go, you will see some good motivational video. You will see, okay, you can crack NEET. You can crack NEET in 30 days also. You can crack NEET anytime. You can crack NEET in 1 day also. Right? You will see these motivational videos. Right? But when it comes to studies, I will see only very few people who wants to study. Very few people who actually like that, okay, I want to do hard work to get where I have dreamt of, like where I want to be. For that, you need to do a lot of hard work. You can't be a doctor like that. Hai? So, have patience, right? At least now when you are just 5 months away, right? So, have patience, right? Okay? Yes, ma'am, I am JE aspirant, but I am watching it is more useful, ma'am. Yes, very good, Varish. Definitely, I'm so happy about that. That's the kind of students like Varish, they are here. Why? Right? Why they are here? Right? They're just one month away from JE because they know the importance of these kind of sessions. Okay? So, don't lose the patience, right? These 3 to 4 hours are going to be worth it because I'm going to teach you all the naming reactions. We are going to do all the previous year questions as well, right? No, I am not skipping dinner. Don't worry. I'll just give you the break. In the break, I'll have the dinner. Don't worry about that. Okay, I'll also give my students the break to have the dinner. Firstly, I'll finish the reactions. After finishing the reactions, before starting the previous year questions, we will have like good break of 20 minutes. Okay. Firstly, let us complete these reactions. Okay. Now, Kolbe's reaction. In Kolbe's reaction, what you have? This phenol is converted to salicylic acid. Salicylic acid. Very good for acne. I know it better. Right? So, salicylic acid it is converted to. Now, here what we do, we add NaOH. It is converted to O negative and positive. Then, in the acidic condition, basically, wait a minute, CO2, on adding CO2, right, and H positive, it will get converted to COH. You're like, ma'am, this is pure cramming. What is the mechanism, ma'am? So, firstly, let us see the mechanism as well here. This is the mechanism as you can see, right? This is phenol. Firstly, what will happen, right? On adding NaOH, here it should be NaOH, right? NaOH, it will act as a base, right? What a base will do? A base will abstract H positive from here, right? When the base will abstract H positive, it will become a phenoxide ion. We know that phenoxide ion has a resonance. This electron will be converted here, will be shifted here, this will be shifted here, and hence this is one resonating structure that you will have. Now see, you have the carbon dioxide. We know that in carbon dioxide, this is partially negative, this is partially positive. Now, this is negative, this is positive. That is why this negative is going to attack here, and this carbon dioxide will attach on this position, right? Okay, we know that carbon cannot handle 5 bonds. That's why this bond will shift here, because carbon is not pentavalent. And hence you will have the formation of this thing. We are almost there, right? Now, what we have to do, this bond will shift here because we have to make carboxylic acid here. So what will happen? This electron will shift here, H will be shifted, this bond will shift here, H is internally shifted to this O negative. What is happening? This electron is shifting here. See what will happen? This electron is shifting here, this pi bond is shifting here, right? Here you will have which thing? You will have this single bond, this is O negative, right? And this H positive will be placed here. And hence you will have the formation of OH here, right? Okay, this bond you will form, this bond will be formed. Here you will have O negative to which H positive will attach, and this thing will be formed. Now, you just need to add Na positive. Firstly, when you add Na positive, because Na positive is already there in the solution. Some students ask, ma'am, why directly you have not added H positive? Arey, I am not adding that. It is already there in the solution. In the solution, you have NaOH. NaOH from this Na positive is going to attach here. After I have this sodium salicate, then I know that I will add H positive here with acidification. Then I'll have the formation of salicylic acid. Okay, so answer will be salicylic acid, right? Okay. Hope you don't need to use salicylic acid, ma'am. Thank you, yaar. Thank you. Your wishes, like I really hope your wishes will grant and I don't have to use this salicylic acid more. This has become my life. Okay. Now next is Reimer-Tiemer reaction. So it is quite similar. From phenol you have salicyl aldehyde. Salicyl aldehyde. Okay. Instead of CHO, you have COO. Instead of COH, you have CHO. Now, here you are using chloroform, NaOH and H positive. Very important point about this reaction is the intermediate is very important. Anybody in the chat box, this is your NEET PYQ only. NEET previous year question, a simple question has been asked in NEET. Right? Intermediate is dichlorocarbene. That is CCl2 and this is your carbene, right? This is your intermediate. Very, very important question. This is your again NEET previous year question. Okay? Yes? Okay. Now let us see the mechanism how this dichlorocarbene has been formed. As you can see here, how it is formed. First you will have a chloroform. Acha, everywhere I am telling the same thing. Base will do everywhere. You will see all the reaction base is doing the same thing. Base first will take out the proton. It is proton acceptor. It will take out the proton. This bond will shift here. You will have C negative CCl3. Right? After this, what will happen? This Cl negative will be eliminated. Right? And from there, you will have the formation of CCl2 dichlorocarbene. This will be formed. This is the basically not intermediate. I'll just erase it here. Not intermediate. This is the electrophile. Okay. This is the electrophile. Electrophile means this is electron deficient. Usually students what they think is, ma'am, this is lone pair. Ma'am, how come this is electron deficient? Guys, this is the beauty of carbene. This is not regarded as lone pair, okay? So basically, how many electrons it has? This is C, Cl, Cl and 2 electrons here, 2 electrons here, 2 electrons here. 6 electron it is having. So it is not, octet is not complete here. So that's why it is an electron deficient species, okay? Now, this is the mechanism, okay? Let's go through the mechanism, right? Now, what will happen? Again, doing the same thing here. NaOH, what is the work of NaOH, guys? NaOH is going to take out the proton. Okay, its simple work is to take out proton. Right, so it is going to take out proton. This bond is going to shift here. You will have phenoxide. Then the same reaction you are going to do here. Right, okay. Now, this has changed. In Kolbe's reaction, you had carbon dioxide. Here you don't have carbon dioxide. You have a CCl2. Till here everything is same. After this things will change. After this things will change. Till here everything is same here, right? So now what will happen? Everyone, now what will happen? This is CCl2. This carbon is electron deficient. This is electron rich. That is why it will attack here. Basically, now here they have pointed the arrow as a wrong arrow. Okay, this should not be the arrow because it is always towards more electron density to less electron density, right? So from more to less, it will attack here. It will attack here basically, and you will have C will attach here. You will have CCl2, right? Here you will have this H and this, right? Now guys, see one thing, what will happen? Basically this, again here also one thing is wrong, right? This carbon, this negative should not be present here. Rather, this negative will be present here, okay, on the carbon. The negative will be present on the carbon, okay, not on this carbon, but on this carbon, right? Okay, when it will attach here, the negative will be present on the carbon, right, to complete the octet here. Because now it is having 1, 2, 3, 4, 5, 6, 7, 8 electrons. Carbon is happy, I have octet is complete, right? Now what will happen? Again the same thing. Hydrogen will, this bond will shift here. This hydrogen will be internally shifted, not internally shifted, yes, it is not internally shifted here. The pi bond it will form here. Here it will form the pi bond. These electrons will shift here, and here you will have O negative. Now this hydrogen is internally shifted to this side. In the Kolbe's mechanism, the hydrogen was internally shifted to this side. That's the only difference, okay? So here the hydrogen is internally shifted to this side. So this is CHCl2, this is O negative. Now once you have reached here, everything else is very simple here, right? There is just one difference. This H is shifted on this carbon here, right? Rather than that oxygen, because it is already present. Carbon is already present. There it will be present after the resonance, right? Now, O negative is present here. Now what you will add? Add KOH aqueous, right? Add NaOH aqueous. We know that NaOH is already there in the solution. Because of that NaOH, this Cl will be replaced by 2 OH, right? We know that one carbon cannot handle 2 OH bonds. It is very difficult for the carbon to handle 2 OH. What will happen here? What will happen here? This is your OH. So what will happen? OH negative will be eliminated. H will be eliminated, right? And this bond will shift here. And hence you will have the formation of C double bond OH, right? This thing will be formed. Got it? What will happen here? I'm going to write it here as well. COH. This is COH. What will happen? H will be eliminated, this bond will shift here, OH will be eliminated, hence you will have the formation of C double bond O, and H is already present here, right? So aldehydic group will be formed, and just after that add just H positive here, right? Okay, and you will get the formation of salicylaldehyde. Okay, got it? Yes. Okay. Okay. Rajkumar, right now just focus on the studies, okay? Nothing will happen if you get demotivated. You are only going to waste your time, okay? Everyone feels demotivated. I know you guys are feeling demotivated right now. But see, there is no use, right? If you keep, demotivation will come. If you keep, if you're not able to ignore that demotivation, then what will happen? You will end up wasting your time. Again, you will be, you will be in that loop that, okay, I got demotivated, I wasted my time, now more demotivation, now more wastage of time, no more demotivation, more wastage of time. You will get stuck in this loop, right? So whenever you feel demotivated, just keep that thought aside. Just tell yourself, ma'am is teaching, I'm going to learn. I am going to learn. I am going to focus. Okay, just focus on that thing. Okay, yes. Now, next is Kirchhoff's reaction. Now, most of you know this reaction, but you don't know that this is, the name of this reaction is Kirchhoff's. Okay, so the answer is Kirchhoff's reaction. Now, what is this Kirchhoff reaction? I'll just tell you. See what will happen. Here you are doing the hydration of alkyne. So what will happen when you do the hydration of alkyne? For example, I'm using one more example here. This is CH3, this is H. Now you tell me what will happen here. When I do hydration here, this pi bond will break. Okay, one pi bond will break. I'll just break one pi bond. This is CH3. Now, can you tell me when the pi bond will break, positive should be on which side, negative should be on which side? If I put positive here, negative here, positive is more stable due to inductive effect of CH3. If I put positive here and negative here, now negative is unstable because of donation of CH3. So that is the reason I am going to put positive here, right? I am just not going to tell you there is positive, there is negative. There is reason behind everything in science. We are studying science, so there is logic behind everything, okay? So this is positive. To the negative, attach one hydrogen. That means this will become H2, right? To the positive, add OH, negative, because we are doing the hydration. So to the negative, add OH, right? So this will be the answer, right? Now, can you see this is enol form? This is enol form. Now, with the help of tautomerism, right, we are going to change the answer, and that is called, not change the answer, we are going to convert it into ketone. Simple trick I told you. 1, 2, ka 3. Okay, 1, 2, 3. What you do after this? First, you just write it as it is. Okay, write it as it is. Write it as it is. Okay. Now, I am telling you 1, 2, 3. Break the bond of 1 and 2. Attach that bond on 2 and 3. Then this hydrogen is shifted to the first position. You have the formation of ketone here. Right? You have the formation of ketone. Break the bond of 1 and 2. Then attach that bond to this 2 and 3. This H is shifted to the first side. Okay? Yes. Okay, guys. Dinesh, don't worry. After this, we are going to do the questions. Right? Okay? Don't worry about that. Right? Okay? Questions you will be only able to do. That's why I have picked out like around 70-80 questions I have picked out for you. Not 70-80, that will be too much. I think around 40 questions I have definitely picked out. Right? Okay? So, if you see today's lecture, like definitely you will see some question, not some question, maybe 7 to 8 question you can easily get from today's, not even 7 to 8, maybe more than that, right? So that you can easily get from today's lecture, okay? Now, next is Rosenmund reduction. Anybody in the chat box, what is Rosenmund reduction? Rosenmund reduction. Rosenmund reduction is H2PDBSO4. Again, we are using Lindlar's catalyst, right? Okay. Now, what we are doing here? We are converting this hydrogen into, basically, I'll just delete this thing here, right? We can write it in better way. That is, this C double bond is as it is, but Cl is converted to H. That is the difference. This is the Rosenmund reduction. Okay, again, this has been frequently asked in your NEET, right? Okay. Next is Stephen's reaction. Stephen's reaction. Everybody, Stephen's reaction. Everybody in the chat box, Stephen's reaction. What do we do in Stephen's reaction? You have RCN. When you add SnCl2 and HCl here, right, tin chloride you are adding here, it is this RC triple bond N. One pi bond will break and you will have the attachment of hydrogen and hydrogen here. This thing is called imine, right? This is called imine. After this, you will do the hydrolysis. This full will be converted to double bond O. That is called ketone. And this full process is called Stephen's reaction. Okay? This is called Stephen's reaction. Okay? This is called, guys, Stephen's reaction. Very simple. Very simple. Okay? Next is 33. That is 𝐂𝐡𝐞𝐤 reaction. Again, this has been asked so many times in your NEET, so many times, right? Now, here you have toluene. Okay, the starting product, the starting reactant is toluene. Now, in the toluene, you have chromyl chloride. You will add chromyl chloride. Now, in this case, this you will have the formation. You also use carbon disulfide here, right? Now, what will happen in that position? You will have the formation of this OCr. This maybe this chromium. Not this chromium complex. Okay, you can just use chromium complex. Chromium complex is formed here, right? That is, in bracket you have OCr, OHCl3 twice. Now this whole thing will be converted to double bond O after hydrolysis, right? After hydrolysis. And this is the formation of the benzaldehyde with toluene using chromyl chloride. Okay, using chromyl chloride. There is one more reaction like this. If in this you add, you will get the same thing. You will get the same thing. If you add CrO3, yes. CrO3 in presence, I think that was NaOH or something. I'm not sure about that. That was, I think CrO3 was definitely there. I think after this you had NaOH. Yes. Okay. So CrO3, by CrO3 you will be able to answer that. Okay. If here is CrO3 also, then also it is going to give you benzaldehyde only. Right? Okay, but that is not 𝐂𝐡𝐞𝐤 reaction. 𝐂𝐡𝐞𝐤 reaction is this one. Okay, that is a general reaction. Then you have Gattermann-Koch reaction. Now, Gattermann reaction was different. Gattermann-Koch reaction is different. Now, guys, in next 20 minutes, I am going to do some very, very important reactions. Gattermann-Koch, Aldol, cross-Aldol, Cannizzaro, Hofmann bromamide. Then you have Gabriel phthalimide, HVZ, Helvohard-Zelenski, and all these reactions are very, very important. So next 20-30 minutes are going to be like snatch the marks. Okay? Okay, guys? Okay, everybody? Yes, very good. Yes, definitely it is also used to form cis-alkene. Okay, from alkyne. Okay, ready for the next part? Now, let us see Gattermann-Koch reaction. Right, just remember this with Koch. OCH. By this you can say CHO. Right, so you can just remember this thing. In Gattermann, you had chlorobenzene, bromobenzene from disonium chloride. But in Gattermann-Koch, you have the formation of benzaldehyde. Right, benzaldehyde is formed. Now, this is quite similar to Friedel-Crafts acylation. Right, why? Because in Friedel-Crafts acylation, what we do here, if you use CH3, C double bond of Cl in anhydrous AlCl3, right, you will get the formation of the nuclei, the electrophile that you will get is CH3, C double bond O positive. This will attack here and you will get C double bond of CH3, right? Now, see this very carefully. Do you agree that this is your Friedel-Crafts reaction, right? Now, if I am saying that you need to attach not CH3, you need to attach H here. Because what is this? Tell me, what is this? What is this CHO? This CHO is nothing but this is basically, this is C double bond OH. So that means if I want to do the same thing with the help of Friedel-Crafts acylation, what I'll do? I'll just replace this with H. That means here also I'll replace this with H. Right? That means here also I will replace this with H. Isn't it? I will replace this with H. Now I'm going to tell you a very, very important thing here. Why we are not following this method? Why we are following this method? Because anhydrous AlCl3 or CuCl is same only, right? We are using CO and HCl, not using HCOCl. Reason is this formyl chloride is not stable, so this reaction will not occur. this HC double bond O Cl formyl chloride is a unstable compound. That's why we need to prepare this in the reaction itself. That's why we are using carbon monoxide CO with HCl, so that we can directly prepare formyl chloride in the reaction mixture only. Then this can make this electrophile here and it can directly attach here. Right? Okay. Okay, got it? Right, everybody? Got it? That why we are using this is Gattermann-Koch reaction. Next is two very important reaction, Clemmensen and Wolff-Kishner reduction. Right? So here this double bond is converted to 2 hydrogens. Here also this is converted to 2 hydrogens. Right? Okay, this is what we are going to do in the Clemmensen and Wolff-Kishner reduction. But the reagents are different. Reactant is same, product is also same, byproduct is also same. But the reagents are different. Definitely byproduct will also be different a little bit. Reagents are different. But yes, the main product and the reactant are same. So guys, see in Clemmensen reduction, right, what will happen? You will use zinc amalgam in acidic condition. But in Wolff-Kishner reduction, you will use hydrazine in basic condition. So this is what is important, that in Clemmensen reduction you have acidic condition, but in Wolff-Kishner reduction you have basic condition. Here we are using zinc amalgam, here you are using hydrazine. Okay, here you are using hydrazine. Okay, got it? Got it, everybody? Got it? Yes, everyone? Yes. Now, next is 2-3 distinguished tests that we have. Tollens test. Okay, Tollens test is basically, actually it is silver nitrate that is formed here. It is in, if you see the oxidation number, that is Ag positive, and here you have Ag 0. So this silver mirror is formed in Tollens test. Basically, aldehydes will give the Tollens test. Okay, ketones will not give the Tollens test. This is a distinguished test of aldehydes and ketones. Right? So here this aldehyde is converted and oxidized to carboxylic acid. This is also the preparation of carboxylic acid, you can say. This is also the oxidation of aldehydes, and this also is the distinguished test of aldehydes from the ketones. Right? Next we have Fehling test. Now in Fehling test and Benedict. Now Fehling and Benedict are very same, almost same only. There is just one difference here. Right? So Fehling test is also applicable for aldehydes only. Right? But in Fehling test, in Fehling A solution, there are two kind of solution, Fehling A and B. Fehling A and Fehling B. So if you talk about Fehling A, that is copper sulfate. Fehling B solution is alkaline solution of sodium potassium tartrate. That means this is your Fehling A solution, right? Now this is what will happen. This, because of this alkaline, because this NaOH, you will have the formation of Cu2 positive. Now guys, this is giving you deep blue colored complex when we mix Fehling A and Fehling B together, right? After this deep blue color will change into the brown red precipitates, right? Because it will convert this RCOHO into RCO, that it will oxidize the aldehydes, and it itself will be converted into Cu twice O precipitates. That will be brownish in color, right? Now, next thing is, ma'am, what is the difference between Fehling and what is the difference between yes, Yash, you can watch till I teach NEET previous year questions. After that, I will not advise you to watch, because after that we will do NEET previous year questions. But till the time I am doing the theory part, you can watch, right? Now, this in the Benedict solution, right? And one more thing, Yash, if you're preparing for JEE, then some other tests are also like added, okay? Some other naming reaction and tests are also included here, right? But these are definitely there. right? So if you talk about Fehling test, you have tartrate, right? But when you talk about Benedict test, in Benedict test, you have citric acid. Citrate you will have, not tartrate. You will have citrate here, right? Understood? In Benedict, you will have citrate. In Fehling, you will have tartrate. That is the difference. Okay, other things are very similar, exactly same. Even the reaction is exactly same. Even the answer is exactly same. Reddish, brownish red precipitates. Now, ma'am, why there was this need? Because in Fehling solution, what happened? No, we have to mix those solutions because those two solutions are not stable, right? So they are not very stable for a very long time. So we have to prepare those two solutions before the reaction when we want to do the test, right? But Benedict's test is stable. Benedict's Fehling A, Fehling B will be stable. This basically this is more stable. That is why we can keep this, right? And this can be used anytime, right? Okay, that's why this was done. Okay. Next is haloform test. Very, very important. Okay. Mark it very, 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 very important. Definitely you will see a question here, right? Okay. Now, firstly, what we do, three things you need to focus here. First is what are the reagents? Then, what is the group that shows this effect, right? Now, and what is formed here? So, firstly, let us see the reaction. Don't focus on the reactant here. You will have any aldehyde or ketone. I'll tell you what are the aldehyde, ketone, or even the alcohol which show iodoform test. I'll tell you that, okay? First, you just need to focus on what are the reagents. The reagents will be either given NaOH and X2 or they can give you NaOX. Now, mostly you will see iodoform test, okay? So, if you place this X, if this X is equals to I, then CHI3 is basically of yellow color, right? Okay, CHI3 is basically of yellow color, okay? So, this is called the iodoform test. This is of yellow color. Yellow colored is formed here. Now, we have seen the reagent. We have seen what is iodoform. This is called haloform. This CHX3 is called haloform. If instead of X you have iodine, then you call it iodoform, which is yellow in color, right? That is important. Now, what are the reagents? What are the reactants that will show this reaction, this test? Okay, mark this very, very important, very, very important, right? Firstly, any aldehyde or ketone which has this group. Any aldehyde, ketone, if it is having CH3 directly attached to the methyl, directly attached to the carbonyl carbon, then it is going to show iodoform test. You need to identify this group. Now, ma'am, what about alcohols, right? What kind of alcohols? Now, anywhere you see this kind of alcohol, just add hydrogen here. Just remember this thing. Okay. Then break the pi bond, add hydrogen. This is the second condition. Okay. This is the second condition. If you see this anywhere, students cram, ethanol will show. Ethanol is same like this, na? What is ethanol? Ethanol is CH3, CH2OH. That means it is basically CHH. Isn't it the same thing? Can you identify this group here? CH3CH, right? So this is the same group. Wait a minute. If I want to write it in a much better way, then I'll write it like this. Okay. Okay. If you identify this group or this group, you will see it is going to show iodoform test. Okay. Chalo, koi baat nahi. It is going to show the iodoform test. Okay. I just want to decrease the box here, but I am not able to. Chalo, koi baat nahi. No issues. Okay. So these two are going to show the Yes, it is not one of the previous year question. You will see this, I think so many, this has been repeated, like repeatedly the question are asked on iodoform test, right? So this will show iodoform test. This will show iodoform test. I'll also show you the previous year questions here. Okay, it will show iodoform test. Iodoform test. Okay. Next we have is aldol condensation, right? Aldol-Cannizzaro, right? Aldol-Cannizzaro reaction. Let us see that. Okay, let us see the. Thank you so much, study. Thank you so much. Aldol condensation. Okay, aldol condensation again with Diksha ma'am trick. Okay, again with Diksha ma'am's trick. Okay, yes. Okay, shall we do that? Now in the whole session I asked you that you don't need to have notebook and pen along with, just listen to what I am teaching. But can you do one thing now? Can you just take out one pen and one page or any notebook so that you can also write along with me? Because this reaction you won't be able to understand. Why I have not written anything here? Because they are not fixed product that will be formed here, right? There is no direct reaction that I can just say, okay, this is the reaction, this is the general reaction, right? This is a proper step that you have to follow here, right? So let us solve this together, okay? Aldol condensation, right? Firstly, aldol condensation requires which thing? Alpha hydrogen should be present. If alpha hydrogen is present, then aldol or cross aldol is possible, otherwise it is not possible, right? Now we will do aldol condensation here, right? Let us do aldol condensation, right? I am going to just write it here, CH3, CH3, CH3. I'm just going to write this thing here, right? I'll say, ma'am, what you are doing, because for this we need two products, two reactants, right? Firstly, what I'll do, just do the same what I am doing. When you have aldol, both the reactants are same. Okay, so how we have to write it? CH3, CH3, just write CH3, CH3. This is, wait a minute. This is CH3, C, double bond O, H. Okay, for one part, you have to open the carbonyl carbon. For one reactant, open the carbonyl carbon. For the other reactant, open the alpha carbon, like alpha hydrogen you should see. Right? That should not be in a closed structure, right? So what I am saying, in the second molecule, what you should open? There should be alpha hydrogen you should see individually. But you don't need to open this structure, that is C double bond OH. Just write it CHO, right? Firstly, is this step clear to everybody? What we have to do? Two reactants you have. First you will write it this way, other you will write it this way. Now directly I'll tell you how to write the answer here, right? After writing the answer, then I'll teach you the mechanism, right? Because tricks are important for competitive exam. Mechanism, you just need to go through the mechanism, okay? So focus on the tricks more, right? Now, here you have, this is the alpha carbon, this is the alpha hydrogen, this is the carbonyl carbon, right? Now understand one thing, what you have to do in the reactant, in the answer, here, write it as it is, write CH3 as it is, write CH3 as it is, then write this carbon. Now this will be O negative, break the pi bond, because we have opened it, that means some reaction we are going to do here, right? That means something we are going to do with this part, right, and this part, right? So let us see what we are going to do here, right? So this will be eliminated. Now mark this as O negative. Place the hydrogen here only. Now attach these two things. Attach these two things. This carbon with this carbon. The carbonyl carbon of one reactant will be attached to the alpha carbon of the other molecule, right? Okay, the carbonyl carbon of one molecule is attached to the alpha carbon of other molecule, right? Okay, so what we are going to do here, when we attach these two, you will have C here. If you want to attach it here, you can attach it here as well. You can write hydrogen here, right? So it will be C. Now C is having two hydrogens here. It is having one CH2, right? This hydrogen is shifted to this O negative. So hence you will have H here. Understood? Understood, guys? This is how you're going to form the products. Are you able to do this? What I did? Attach this carbonyl carbon with the alpha carbon. This hydrogen will be transferred to this oxygen here. And this pi bond will be shifted here. Right? Okay. So, CH3, CH, wait a minute, I'm just going to write it in a small fonts. This is CH3, COH. Convert double bond, or you can just simply say convert double bond O to OH, then attach this to this one, right? Okay, then attach this to this one. This is CCH2, then complete the valency by hydrogen. This is H, this is CH2, this is CHO. Now, this is your aldol product because you have aldehyde and you have alcohol. Now, also condensation. This is proper is aldol condensation. After that, water will also be eliminated. But how the water will be eliminated? See, from the alpha position, from this position, OH will be eliminated. From this position, you will have hydrogen will be eliminated. This bond will be shifted to this side, right, where OH was eliminated, and hence the answer will be CH3, CH double bond, CH, CHO. This is called, so many questions are asked here on this. This is called, for this aldehyde, this is alpha, this is beta. So this is alpha beta, this is called alpha beta unsaturated aldehyde is formed. Aldehyde is formed. Okay, alpha beta unsaturated aldehyde is formed here, right? Okay, yes, okay, understood. Okay, understood. Now, guys, everybody tell me, are you able to use the trick here? Are you able to use the trick here and apply it here or not? Right? Okay? Are you able to use the trick here and apply it here or not? Right? Okay. Shall we move ahead? Shall we move ahead? Right? Chal. Now, next is this one. Very good answer, Harish. My kids are here to answer you. I don't even need to answer you. Because I have my army. They will answer you. Now, this is the mechanism. Now you will find it very tough. Then, ma'am, what is this, ma'am? Okay, so don't worry. I'll just go through this. You don't have to cram this. Just go through this. Okay, just see that, okay, ma'am is teaching something. We just have to understand. Okay, what if they ask you some statement-based question from? Very rare chances, but still, okay, just go through this very simple mechanism. You have this carbonyl. What is the work of a base? So here the base is basically taking out the alpha hydrogen here. This is CH2 and this is H. Base is going to, what is the work of a base? Base was also what base was doing in Kolbe reaction, what it was doing in Reimer-Tiemer reaction. It was always taking out the H positive. So it is going to take out H positive. This electron will be shifted here. You will have the formation of this electrophile, right? Now, this is existing in 2 resonance, but it will attack in this way only. It will attack with this way only. Now, we know that other molecule is this one. Here, this is partially positive, this is partially negative. Now, this is negative, and this is positive. They have made the same molecule here, right? So, this is negative, this is positive. That is why it is going to attack here. Because electrophile is, sorry, this is a nucleophile, right? So, nucleophile is attacking on the positive position here, where you have less electron density. It is going to attack here. Electrons are going to move here. You will have O negative here, CH2, CHO. After that, guys, simply what will happen? You will add, wait a minute, you will add H here. H will be added. You will have OH here. After that, so very simple, OH will be eliminated, H will be eliminated. You will have the formation of this aldol condensation product. Was it difficult? Was it difficult? Simple, right? Simple. What happened? Base did its work. Right after that, it acted like a nucleophile. It attacked on the nucleophilic position. Now you will have the formation of the product. Right? Okay. Next is cross aldol, cross aldol, cross aldol, cross aldol. Everybody in the chat box, cross aldol question has also been asked to you. Now let's be very serious here, right? CH3, CHO, CH3, CH2, CHO. Now let's draw the products here. First is CH3 can also react with its own molecule. So I'll make both as CH3, CH3, CHO, right? But one will show the carbonyl part, other will show the alpha carbon, right? So here these are the two reactants. Now I'm going to do it in a fast forward manner, right? This is the carbonyl carbon, this is the alpha carbon. Attach these two together, what you will get? CH3, C, convert this double bond O into OH, right? Then this hydrogen will be as it is. This CH2 will be attached here. This will be the answer. Once you eliminate this thing, you will have the formation of CH3, CH double bond, CH, CHO. This is the first product that you will get. This is the first product that you will get. Okay? First product. Second product is, what if this CH3CHO reacts with itself? CH3, CH2, CH3, CH2, C double bond OH. Then you have CHO. What is alpha here? This is alpha, right? So we want to show the alpha part here. Okay, so sorry. Okay, now am I audible? Now am I audible? Yes, ma'am, audio, ma'am, audio. Ma'am got too busy in teaching the compounds here, na? Okay, now, okay. Now audible? Now. Let me see how many likes you have given to me for this hard work. Very good. Very good. Let's make it to 200 likes, okay? Let's make it to 200 likes before we end the session. Okay? Now audible? Acha. Where we were. This is carbonyl, this is alpha. Attach these two. This double bond is converted to OH. Here it is the CH3 and hence OH will be eliminated, H will be eliminated. You will have the second product here. Right? Is this thing clear to you? Is this page clear to you all? Right? Now I am going to make cross aldol. Okay? So now cross aldol, that means one is acting as carbonyl. For one reactant, carbonyl carbon will act. For the other reactant, alpha carbon will act. Other is CHO, CH3. For other, you have alpha, right? So this is CH, this is H. So this is, guys, this is alpha and this is carbonyl. Okay, this is carbonyl, this is alpha. So shall I just attach these two together? Hana? We should just attach these two together. What you will get, what you will get. Very good, very good. Try to make the answer. Try to get the answer here. This will be CH3, right? This carbonyl is converted to OH. Then this is H here. Then this is, both are attached. This is CH. This is CH3. This is CHO. Here also I made. Okay. So this is the third answer that I'll get. Right. After this it will lose water. And what it will get? After this it will lose water. And this OH will be eliminated. H will be eliminated. You will have CH3, CH double bond, CCH3, CHO. This is the third product that will be formed. Okay, this is the third product that will be formed here. Got it? Yes. Very good. Last one is do the opposite here. Okay, do the opposite here. I'm just going to copy paste this thing here. Right, do the opposite here. Opposite means which thing? Here, take CH3, CH2, this as the carbonyl carbon, and take the other one, that is CH2, H, CHO as the alpha carbon. So now this is my alpha, this is my carbonyl. I'll just attach these two together, and what I'll get? CH3, CH2, this is converted to OH, H here only, this is attached to the alpha, so it is CH2 and this is CHO. After this, it is going to lose OH, lose this H here. What it will get? What it will give us? CH3, CH2, C double bond, CH-CHO. This is the fourth product that you will get. This is called cross aldol. Okay? This is called cross aldol. Got it, everyone? Got it, everyone? This is called cross aldol. Right? Cross aldol. Everybody, is that clear or not? Is that clear or not? Right? Shall I jump to the next reaction here? Cross aldol. Very good. Very good. That is clear, right? Okay, very good, very good. Cannizzaro reaction. Okay, Cannizzaro reaction. Simple. Just convert, if it is self-Cannizzaro, firstly it should have no alpha hydrogen. Right? If it doesn't have alpha hydrogen, then this is converted to C. One is converted to basically disproportionation reaction. Okay? You can even write it here. Disproportionation reaction. What will happen? One molecule is converted to the same number of carbon, alcohol, and one is converted to, see, you have C, this is H, this is H, this is converted to alcohol. Then other is converted to, with the same number of carbon, you should have the sodium salt or potassium salt, whatever you are adding. So here you are using concentrated NaOH or KOH. If you are adding NaOH, it will be sodium salt of carboxylic acid. One is oxidized. Why it is disproportionation? Here you are having the reduction. Here you are having the oxidation. That is why it is disproportionation reaction. Okay? Okay? Got it? This is called disproportionation. One is converted to reduction. Other is converted to oxidation. Right? With the same number of carbon atoms. Right? What is the doubt? Write it down. Now, let us see the mechanism. Same mechanism. Firstly, what will happen? This OH negative is going to act as a nucleophile here, not as a base. It will attack here. Electron will jump here. you will have the attachment of OH negative. Now hydride transfer will happen in this place, right? So after the hydride transfer, what will happen? This is your O negative. Basically what will happen, this hydride, okay, this hydride is going to transfer to this molecule, right? This hydride is going to, because here you will have the formation of this acid, this hydride is going to shift here, right? And what you will have, this hydride is going to shift here, this will be H, these electrons will shift here, this will be CH3O negative, right? So hydride shift will happen not internally, this hydride shift is going to happen on the other molecule, right? Okay, next is, after this, now you will think that ma'am, here you should attach Na, but in reality this hydride again is going to shift here, you will have this ion, and then with Na positive, because in the solution you will have Na positive, you will have the carboxylic salt, right? You will have the carboxylic salt. Mechanism you don't need to get into, but I'm just showing you the mechanism so that you don't feel FOMO that I have not studied the mechanisms, because you should at least know how organic chemistry works, right? Next is cross Cannizzaro. This is very important, because my idea is asking Cannizzaro is a very simple thing. They will ask you cross Cannizzaro, right? Okay. Just give me a minute. Guys, do you have some job? There are so many unemployed people. Give them some job, yaar. Very desperate. Okay. Now, this is cross Cannizzaro reaction, right? Cross Cannizzaro reaction, very important. Again, the same thing, but there is a twist here, right? One will be converted to OH, other will be converted to COONA. But ma'am, which will be converted to alcohol, which will be converted to the carboxylic salt, right? Okay. Then gamers, you need to write your doubts. I don't have those many powers so that I can understand your doubt just by sitting here, right? You need to write that doubt. Now, here see, you have CHO, the one which is having less hindrance, right, will form the carboxylic salt. Now, which is having less hindrance, everyone? Which is having less hindrance? Which is less hindered? This is less hindered now, so this will form the carboxylic salt, right? Less hindered is going to form the salt. Okay, so now this is going to form the alcohol, so this will be C6H5CH2OH, because the number of carbon will remain the same. Sometimes students, what they do, they will say, okay ma'am, here phenol will be formed, ma'am. Arey, how? Number of carbon will be same, no? So this will be benzyl. Benzyl alcohol will be formed here, right? Okay, understood? Yes. Next is esterification reaction. Now in this esterification reaction, again a very, very important thing. In esterification reaction, as you can see here, RCOH, R-OH, very simple esterification. What you will do, water will be eliminated and you will have the formation of RCOO. Basically, it will be RCOOR. Ester will be formed here. But the question is, will this bond break or will this bond break? That is the question, okay? Will these two oxygen are from the carboxylic acid, or one is from carboxylic acid, right? And the other is from alcohol, right? That is the question here, okay? That is why we have to study the mechanism. Otherwise, so this is not a subjective paper, right? So here, we will study the mechanism and see which is the bond that we need to break. Okay, so I'll just show you the mechanism and we identify that thing. Firstly, we know that H positive will attack here, this will shift here, this and that, okay, whatever. What you need to focus on? What you need to focus on? Here, this is your OH, this is the OH, this is the OH here. Now, on this place, this OH is eliminated. That is why I showed you the mechanism. This OH is eliminated. That means in the ester, this OR is from alcohol, this RCO is from carboxylic acid. Is from carboxylic acid. Okay, understood? This OR is from ma'am. Now ma'am, what kind of question they can ask you? They can ask you this kind of question. This is RC double bond O. This is having 16 isotopes. This is OH. This is R dash OH. Right? Now they have given me that this is my 18th isotope. This is 16th isotope. This is 16th isotope. Now you need to tell the answer that what will be the correct answer, which isotope will be there in the answer. We know that this in the ester, this is my R dash, this will be R dash. These O and R are from alcohol, so this will be 18. This RCO is from carboxylic acid, so this is 16. This is going to be the answer. That is why this is important. Okay, that is why this is important, right? I am going to give you a break only. Just 5-6 reactions are left. Okay, 5 say I am so dying to get break. Why? I have not eaten anything, not even lunch. I was preparing these notes for you. I haven't had any lunch. Preparing notes, then collecting the previous year question. It took me 3-4 hours. Not 3-4, maybe more than that. It took me 4-5 hours. Yeah. From 12 p.m. I was doing this only. I just had salad and then just joined the class. I thought that okay, I'll give the break at 8 and I'll have some dinner. But now I am so, my stomach is literally starving right now. Okay. Now let us see the next one, that is Helvohard-Zielinski reaction. So in this what will happen, right? This alpha carbon, right? This alpha carbon, this hydrogen on the alpha carbon will be substituted by the halogen that you will add here. For example, you are adding chlorine. This halogen will be either chlorine or bromine, okay? So either, that means you will have alpha mono halo compound. Alpha mono halo compound. Halo carboxylic acid will be formed. That means on the alpha position you will have one halogen here. What are the reagents? X2, that is halogen in presence of red phosphorus, and water, that is the reagent here. Okay. Next, Mendius reduction. What is Mendius reduction? You have RC triple bond N, right? This is actually a increment, that is ascending carbon reaction. You will have the formation of amine here, but here the alkyl chain was R, but here the alkyl chain is R plus one more carbon, right? So this is, that is what is called ascending in nature, right? You have more number of carbon in the alkyl chain. What is the reagent that you use here? Hydrogen in presence of nickel. But one more thing, sodium amalgam and ethanol is also used here, right? Hydrogen in presence of nickel and sodium amalgam is also used here. RCN is converted to break the pi bonds here, break these pi bonds, attach H2, attach H2. This will be formed, okay? Break the pi bonds, attach H2, attach H2. Next, Gabriel phthalimide reaction. What is Gabriel phthalimide reaction? It's like a gabbar, okay? It's like a gabbar. So let us see which kind of gabbar it is, right? Now, let us see that. This is basically your phthalimide only. You can write here phthalimide, right? This is basically phthalimide. Now here you have KOH, RX, aqueous, NaOH and water. And you do the hydrolysis, right? What you will get here, these bonds will break. You will have OH here, and here H2 will be attached, right? And you will have the formation of RNH2. You're like, ma'am, what is the mechanism, right? So let us see the mechanism. Always remember, primary amine will be formed here. Whatever RX you are adding here, to this RX just attach RNH2. This thing will be formed. To this RX, whatever alkyl halide you are adding here, to that X just add NH2. That will be the answer. Okay. Now, Mechanism here is very important, very simple also. Firstly, this H will be replaced by K. H is replaced by K, right? Then this K is replaced by this R, right? Because here you have K positive, OH negative, R positive, X negative. So this H positive and N negative, H is replaced by K, K is replaced by R. Now after this, what will happen? Break these bonds, attach hydrogen, hydrogen here and attach OH, OH here. And you will get RCOOH, right? And this is RNH2, RNH2 you will get, that is primary amine will be formed here. Okay? Primary amine will be formed here. Right? Okay. Okay guys, got it? Got it, got it. Hofmann bromamide degradation, again a very, very important reaction, very, very, very important reaction, right? Here what we do, here this will be eliminated. It will just go, it is decrementing of the full carbon, will just eliminate one CO from there, right? So this will be eliminated and you will have RNH2 as the answer, RNH2 as the answer. What are the reagent? Br2 in presence of NaOH. Br2 in the presence of NaOH, that is the reagent. This will be eliminated. That means amide is converted to amine. Amide is converted to amine, right? Okay, amide is converted to amine, right? Now let us see now here one step is very important, right? So let us see that, right? So what will happen here? Now we are just left with two mechanisms. One is Hofmann bromamide, other is carbylamine. Okay, so just 2-3 more reactions we are left with, right? So this is RCONH2, right? Here base will try to abstract the proton, right? And this will jump here and this will jump here, and hence you will have the formation of this kind of compound, right? Now this is Br2. What will happen? One Br negative will be shifted, electrons will be shifted here. This is positive and this is pi electrons, right? So these pi electrons will attack on the electron deficient bromine, right? And hence bromine will attach here. Now you have this thing. Now firstly what will happen? You have base, right? Again base, just like base abstracted proton from this side, base will again abstract the proton here. It will abstract the proton, electrons will again shift here, this will again shift here. Now what will happen? You will have the formation of this thing, right? Now let us see how we have RNH2 formation. Now bromine will be eliminated, right? Bromine, where this step is very important, this step is very important, this step is very, very important, right? Okay, this step is very, very important, right? And this compound is very important, right? Okay, isocyanate is formed, isocyanate is formed, not cyanide, cyanate is formed, right? Okay, now let us see this. This bromine will be eliminated here. This R will, this is internal shifting, okay, that's why this is important. Okay, in carbylamine also you have same kind of step. So what will happen? Not the same kind of step, but something like this only. Now what will happen? This R will shift here, right? RNCO. Got it? RNCO we want to make. That is why this step is important. That is why this mechanism is important, right? Okay? Because of this, till here everything is simple. This step is important. This R is going to shift here. This R is going to shift on this position, right? Then this pi electrons has shifted here, right? Now here you will have the formation of R. This is R. Then you have N. Then you have double bond C. Then you have double bond O. This is called isocyanate. This thing is formed. That is why this mechanism is important, right? Okay. Then you have isocyanate formation. Then you add water into it. Then what will happen? These bond will break and this will give you RNH2 and carbon dioxide. Okay. This step is very, very important. This step is very, very important. Okay, this step is very, very important. Okay, got it? Okay, this they can ask you which thing is formed here, right? Next is, okay, next we have carbylamine. Now, very, very important reaction. You will see the similar kind of transfer here, right? Here, carbylamine, it is test for primary amine. Test for primary amine. What we do in primary amine, can anybody tell? RNH2CHCl3KOH. Do you remember we have used this in Reamer-Temer reaction as well, right? That is why the electrophile is same. Electrophile is same. I want to see in the chat box what was the electrophile in Reamer-Temer reaction. I want to see that in the chat box. Let us see if you guys remember or not what I have taught you. Right? Let us see that in the chat box. Right? Now, this is RNH2. This is converted to RNC. Right? This is converted to RNC. Very, very simple mechanism it is having. Right? Okay. So, what will happen? In the first step, you will have the formation of, that I was asking you, dichlorocarbene will be formed. After that, because of these are the lone pairs and this carbon is electron deficient, this will attack on this electron deficient carbon and hence this thing will be formed. That is why nitrogen is having positive, because nitrogen is having 4 bonds here. Carbon is having negative because now it has more electron. Its octet is complete, it is happy, right? Okay. Now this is negative. Firstly, both the chlorine will be eliminated. Firstly, we will eliminate one chlorine here, right? One chlorine is eliminated, right? Wait a minute. Wait a minute. Yes. Now, the base will attack on this hydrogen, right? This proton will be extracted. This bond will shift here. And here you will have Rn and this will be your, this will have the positive here. Not the positive, it will have only 3 bonds. But now what will happen? When this chlorine will be eliminated, this bond will be shifted here, right? So you will have Rn, H as it is. Now you will have NC bond here and this only one Cl you will be left with, right? Okay. Now again what will happen? Because this is, again what will happen? This Cl negative will again leave this, right? Now, what will happen? This hydrogen is again base will attack here. This proton will be abstracted. Now, this bond will be shifted here, right? Again, this Cl will leave and you will have Rn triple bond C formation, right? You will have the formation of isocyanide. Got it? Okay. Okay. Okay, so what is important for you to note down here, that dichlorocarbene is the electrophile in Reamer-Temer and carbylamine, and this test is applicable for primary amines only, right? Okay, primary aliphatic or primary aromatic amines. Okay, next is Ginzburg reagent. Ginzburg reagent, what is the Ginzburg reagent, guys? Ginzburg reagent is, firstly, this is the Ginzburg reagent. Now we will see with primary, with secondary. This is the primary. This is actually distinguished test of primary, secondary and tertiary. Okay, so this is benzene, right? S double bond O, Cl, right? Now Rn R dash H, right? It is with, wait a minute, NH R R dash. Secondary amine, again the same thing, that is S double bond O, Cl. This is benzene. Again the same thing, N, this is R dash, R double dash. Plus again the same thing, S double bond O. Now you have to see what will be the answer here. Okay? Okay? Now, H and Cl will be eliminated. You will have the formation of Rn, H will be here, S double bond O, this is benzene. Again HCl will be eliminated. You will have the formation of N, R, R dash. This is S double bond O, and this is your benzene. Again there will be no reaction because we don't have hydrogen here, so that HCl will be eliminated. That is why there is no reaction. Now, simple way to say this is tertiary amine will not react. Primary amine will react, but because of this hydrogen here, they are alkali soluble. Alkali means NH4OH soluble. They are alkali soluble. Here you don't have hydrogen or nitrogen, that is why it is alkali insoluble. Alkali insoluble. Alkali insoluble. And in 3 degree, you will have no reaction only. This is 1 degree, this is 2 degree, and this is 3 degree. Right? This distinguished test is also asked so many times. Okay, this is also important. Got it? Got it, everybody? Got it or not? Yes. Now, next is, and the last one we have, azodite. This is the last one only. Yes. After this though, we will have break of good 20 minutes, right? Good 20-25 minutes we'll have break. And after that, we will again start and finish the previous year question today. So do you guys want to finish the previous year question today itself or not? Because today only we have, completed all the naming reactions. So I have picked out the previous year questions from the naming reactions only. You will not see previous year questions from any other topic of organic chemistry, but only from the previous year questions, only from the naming reactions. Okay? And I want all of you to answer also, right? That will be a fun game that you guys are answering just after revising so much. That will be fun. But before that, we'll have rest. Okay? Give yourself rest. Right? Okay? Last naming, basically this is distinguished test, azodite test. So this is diazonium chloride. When you have phenol, this Cl and HCl will eliminate again, and you will have the formation of this benzene, right? This is N, this is N, basically N triple bond, there will be N here again. This will be benzene, and here you will have OH, right? Again, basically it should be, this will be eliminated. You will have, I'm just directly drawing it. This will be N2, right? And this will be your NH2. Now guys, very important thing, phenol, O, it is going to form orange dye, okay? Let us write it in orange pen only, orange dye. Coupling reaction this is called, okay? Amine is going to, aniline is going to form yellow dye. This will be yellow dye. Okay? Okay. One more question that is asked here. This is basically your previous year question of JEE Mains. But my feeling is that if they can ask you the question in JEE Mains, because JEE Mains and NEET having the same kind of level, so it is possible, high chances, that the same question they can ask you in NEET. Right? Okay? Yes. I think its dye was red color. I'm not sure. I'll see that. What is the color of the dye? But I'll tell you what is the reaction. Okay. So this is, again, this will be eliminated. Right here you will have N2. This is your benzene. Here you will have O. This is basically beta-naphthol. This is beta-naphthol. Okay. And here you will have your benzene ring. Right? So that is the azodite. I think the color is red, but I'll still confirm. Okay? I'll still confirm to you after the break. Okay, guys? Yes, everybody? So, guys, now we have completed all the naming reaction distinguished test till now. But it is still not completed. What we are left with? We are left with the previous year questions here. Right? So I have picked out, if you want to see, I have picked out the previous year questions. You want to see NEET 2015, right? NEET 2022, right? Then you have NEET 2000, this is one only, right? NEET 2014 previous year question, right? Then If you want to see others also, right? Wait a minute. NEET 2017, right? So I have picked out a lot of questions for you and I want to cover those today itself, but only if you have the energy. If you guys feel like, ma'am, we don't have the energy, we want to finish this on some other day, then that is also fine with me. Yellow reddish, okay, yellow reddish. Thank you. So I'll just write it here. Yellow reddish. Yellow reddish is what kind of color? Reddish it should be. I'll tell you after the break. Okay? Yes. Green color? Let's not write anything here. You guys will confuse me. I'll tell you after the break only. Okay? Yes. Acha. Hanji. Okay then guys, I'll see you after the break, and before that let me tell you that we have, if you want more such fast track revisions, that our batch is going on, right? If we can teach you this much amazing on free of cost, and what will be there in the batch, you can imagine yourself, right? So in the batch that is NEET Express, you have live sessions, you have online test pedagogy, you have topic wise recorded lectures as well, at home, offline. See, if you are purchasing Prime, then you will get all these things, but you will not get test series, you will not get NEET crash books, right? Which is still okay, right, for those students who already have test series. But my idea is that test series is very important for you to practice, so I would advise you to purchase NEET Express combo offer. And for those students who don't have any, because so many students are asking, ma'am, I have doubt, right? So for that we have doubt app for you, and for this 24/7 you get a teacher, right? So for that, any time of the day you can ask your doubts. So right, so this is also going to be a really amazing thing, where you will get doubt app, crash books also are available to you, because you will need that, right? You need that quick revisions also, right? So crash books will be available to you, offline test will be delivered to your home, right? And rest of the things are also available in Prime. So my advice is, if you don't have any chemistry teacher like to whom you can ask the doubts face to face, then I would advise you to go for the Express Pro batch. But if you're like, ma'am, there is some Didi or there is some teacher, so school teacher or maybe tuition teacher who can ask my doubts, then I would advise you to go for combo offer, right? Then my advice will be combo offer. But if you don't have, then your doubts should not be left unresolved, because your doubts are unresolved. Then why are you even doing hard work, right? Then just stop doing hard work, because you are having doubt and your doubts are unresolved only, right? So that is the thing for, right? Okay, chalo. Okay, so I'll tell you after the break, then we will see you after the break. Now we have 8:23 and I'll see you all, not 9:23, I'll see you all at 9:50. Okay, 9:50 p.m. I'll see you all. Right? Okay, I'll also have my dinner, right? And after that, I'll see you. Okay, then see you after the break, guys. See you after the break. Let me see how many students have the patience to do the previous year questions along with me. Right? Okay, chal. am I audible? Thank you, ma'am. Mute. Yes. Now am I audible, guys? Okay, perfect. So, welcome back to the class. I think now it's audible. Okay, welcome back to the class, guys. And I really hope so you all had your dinner. I had vada in my dinner, right? Sambar vada. So today my mom had prepared South Indian food. So as I told you, I'm a big fan of South Indian food. So yes. Okay, so are you all guys ready? Vada nice, ma'am. Yes, my mom makes delicious vada. Delicious. Okay, now we are going to start with the previous year questions. But before that, let me know in the chat box if you guys had your dinner. If you all had your dinner or not. Because we want to have that energy, right? And I want all of you to have one pen and notebook because we are going to solve the previous year questions now. Okay? Okay? Chalo. Now let us start the first previous year question on your screen here. Okay, so on your screen you have the previous year question, that is, which of the following, the first question is asked in NEET 2020, right? Which of the following alkane cannot be made in good yield by Wurtz reaction, right? Which cannot be prepared by good yield by Wurtz reaction. So that means it will be unsymmetrical or it will be odd number of carbon, odd number of carbon. So N-hexane, definitely it is even number of carbon. It will be prepared in, ma'am, why didn't you ask me? Why did you eat alone? Because you are not here, no? Otherwise, if you are here, I'll definitely ask you. Now, 2,3-dimethylbutane. 2,3-dimethylbutane means this thing. 1, 2, 3, 4, 2, 3. Now, this is symmetrical. So, we can form this by using this kind of alkyl halide. So, this is also possible. N-heptane is odd number of electrons. So, this is not possible, right? Odd number of electrons will be in very, C is the correct answer. Butane is again even number. See guys, this is this second of this option, as you can see here, right? So if you use this, that means if you eliminate this thing, if you use this kind of alkyl halide, then you will be easily able to prepare 2,3-dimethylbutane. Okay, so answer is C is the correct answer. Next question is on your screen, hydrocarbon. Now they are saying that hydrocarbon. The question is, hydrocarbon reacts with bromine by substitution to form alkyl bromide. Okay, hydrocarbon reacts with bromine by substitution to form alkyl bromide, which by Wurtz reaction. Okay, which by Wurtz reaction? No, you have a hydrocarbon. We have no idea which hydrocarbon they're talking about. With the bromine, this is reacting with bromine by substitution to form. So, substitution reaction will occur, right? And you will be able to form alkyl bromide. That means RBr, right? It will be formed. So, that means this will be your alkane. This will be alkane. Because only alkane on substitution give RBr, okay? So that must be RH. H will be substituted by Br. Now he is saying after Wurtz reaction, it is going to give gaseous compound containing less than 4 carbons. Very, very beautiful question. 2018 it is. Now he is saying that this, you have to identify what is this alkyl group, what is this alkyl chain, right? So RH on Br2 substitution, that means Br2 H mu, on adding Br2 H mu, it is going to give RBr, and this carbon, this after Wurtz reaction, it should have less than 4 carbon. See, less than 4 carbon means either 1 carbon or 2 or 3. Now tell me, is 1 carbon methane possible in Wurtz reaction? Is methane possible in Wurtz reaction? No, that was a limitation. Odd number of alkane is possible in Wurtz reaction? No, that is also not possible. That means the answer will be 2 carbon alkene, right? That means this thing, right? That means here it will be CH3, CH2, Br. Oh, if you're saying double of this, that means here it should be CH3Br. Because double of this will be CH3, CH3, right? Double of this will be CH3, CH3. So here, answer will be CH4. On reaction with Br2HMe, it will substitute hydrogen with bromine. After the Wurtz reaction, this will double and you will have the formation of ethane. They are asking you the compound A. That means this compound they are asking you, that is D, that is D for Diksha ma'am, D for Dosa ma'am. CH4 is the correct answer, okay? CH4 is the correct answer, right? Okay. Very good. Target logged CH4. Shabash. So, you got the correct answer, okay? Next question is most suitable reagent, 2019 question it is, most suitable reagent for the following conversion. You have to do the following conversion. They are asking the most suitable reagent for the following conversion is what? Most suitable reagent you have to tell. Most suitable reagent. This is alkyne, right? Now you have to prepare cis alkene. I told you. Cis alkene. I think easily you can answer this. Within 1 second you can answer. We have just done these kind of reaction. Okay, I'll give you one hint. Either it's Lindlar's catalyst or it's Birch reduction. Very good. Shabash. Very good. C is the correct answer. That is Lindlar's catalyst. That means H2PD carbon. It is poisoned by quinoline. Okay. So answer is C is the correct answer. You can also write here the name. Okay. Next question we have, predict the correct intermediate. Now they are saying predict the correct intermediate and product in the following reaction. Okay, everybody tell me what was the name of this reaction. Let me see if you remember this or not. Right? Okay. Option A is colored here. I think by mistake. By mistake that is colored, okay? By mistake that is colored. Not the correct answer, okay? Now, tell me this alkyne to intermediate then to product. Firstly, if you have these reagents, what will be the name? Do you remember? Kirchhoff's, okay? What was the name? Kirchhoff's. Kirchhoff's. That was the name of the reaction, right? That was the naming reaction name. Now, this is CH. Have we done? One of the students was saying, na, this is your previous year question, ma'am. Yes, 2017 I gave you the example, exactly same example I gave you. So what will happen? One pi bond will break. Here you will have positive, here negative. It will be CH3, C double bond CH2, and here you will have positive. That is why here you will have attachment of OH. After tautomerism, what you will have, everyone? 1, 2, 3, break the bond of, right? Break the bond of 1 and 2, attach it to this. The hydrogen is shifted to this side, right? That means you will have the formation of ketone here, right? This ketone is formed. So here you have CH3COH CH2. This is not B, this is not B, this is B. CH3COH, so C will be the correct answer, okay? C will be the correct answer, not D. C is the correct answer, okay? Yes, C is the correct answer, 3 is the correct answer, okay? Next. In the reaction, anybody in the chat box, what is this reaction? Anybody in the chat box? Anybody in the chat box? What is the name of this reagent? If you do this, what is the name of this reagent? What is the name of this reagent? This reagent is called in the Birch, this is basically used in the Birch reduction, right? Okay. No, not in the Birch reduction. This is NaNH2, right? So a base you have used, liquid ammonia. This though I have not taught you today, na? I think this I have not taught you today. I think by mistake I have bought this question. This is a different question. Okay, guys, I am deleting this because this is not the naming reaction, right? That is not. I think by mistake I bought that, right? So that is not the naming reaction. Okay. Now let us do this question here. The compound A on treatment with Na gives B. Compound, there is some compound A on treatment with sodium, it gives B. Definitely, if there is some use of sodium, that means this must be Wurtz reaction, right? That's a feeling that it must be Wurtz reaction. 2018 question. And with PCl5 gives C. That compound A with PCl5, it will give you C. Okay. B and C react together to give diethyl ether. Firstly, let us go in the reverse manner. Okay. Let us go in the reverse manner. So A, B, C you have. Firstly, we have to see the C. C is diethyl ether. Ether means this. Diethyl means C2H5 here. C2H5 here. Right. This you have formed when B and C react together to give diethyl ether. That means there must be some Williamson synthesis, right? That is a formation of ether, right? So it is possible that one is your halide and one is alkoxide, right? I don't know. I definitely know that this is C, right? To give diethyl ether, B and C. So out of this, either this is B or this is C, or this is B or this is C, right? Because we are using Williamson synthesis reaction here. Now he is saying that PCl5 with sodium it is giving B and with the PCl5 it is giving C. PCl5. If you have alcohol on sodium, yes. If you have alcohol, if you have this alcohol, see, if you have this alcohol, that is C2H5OH. On reaction with PCl5, this will be replaced by C2H5Cl, right? And if you react this alcohol with sodium, this will be replaced by C2H5ONa. So can I say this is A, this is B. What is B? B is formed by Na, right? So this will be B and this is C. Okay. So A is your alcohol C2H5, B is C2H5ONa, C is C2H5Cl. So D is the correct answer. Okay. D will be the correct answer. Okay. Attack the D point. Okay. I have attacked it. Right. So D will be the correct answer. How many of you are able to answer these? Right. Okay. So D is your correct answer. Next we have 2019, little bit old question. Which of the following reaction is an example of nucleophilic substitution reaction? As you can see, in 2018, they are asking you good question, okay, which you need like more brain, hai na? So you need to do 2-3 things you need to know, only then you can answer, right? Here they have asked a very, very simple question. So here they have asked a very, very simple question. Which of the following reactions is an example of nucleophilic substitution reaction? Nucleophilic substitution. This is a free radical, right? This is also not nucleophilic substitution. This is also nucleophilic substitution. It is basically there is no substitution happening here. So This is nucleophilic substitution where this X is substituted by this OH, right? So D is the correct answer. That is nucleophilic substitution reaction. Okay, D is the D for dosa ma'am. Dosa ma'am is today very famous. Huh? D here, D here, everywhere D, 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 D. So dosa ma'am today is very famous. Huh? Okay. Now next question is this one, as I told you, from cumene. Chalo, I have given you hint, right? So as you can see here, you have cumene. So that means cumene process you are using here. Cumene is isopropyl, okay? 2019, latest question it is, right? So here I told you what will be the intermediate. You will have this isopropyl here, CH3. CH3 in presence of air, it will have a peroxide bond. This bond it will have. So it will have COOH bond. C will be the correct answer. Right? After this, it will make phenol and acetone. Right? After this, phenol and acetone will be formed. So C is the correct answer. Very good. C is the correct answer. Right? C will be the correct answer. Very good. Now, next is 2018 question. The reaction is this, right? Now, can you tell me what is the name of this reaction? How many of you can tell me what is the name? What is the name and what is the electrophile? Told you that this was your recent question only. What is the name and what is the answer here? Okay, let us see that. Ma'am, I got 6:45. Should I watch again lecture or do only revision and question practice? I would, the sincere advice is do practice, okay? Because if you have scored 6:45, that means your concept is clear, and see what are the mistakes that you have done before and practice as much as possible, right? Okay. Now you have NEET 2018 question. The answer is very good. Riemer-Tiemer reaction this is. And what is the electrophile that is formed? Dichlorocarbene is the electrophile. D will be the correct answer. So, D is the correct answer. Again, Diksha ma'am is winning here, guys. Diksha ma'am is on like literally everywhere, right? I don't know when on YouTube I'll be everywhere. Can you hear the sound of these crackers? I don't know why, like already the atmosphere is ruined, right? Why people are again, burning the crackers and making the atmosphere even worse to take breath. So to breathe. So I don't know what's wrong with people. Like, why so much crackers? Even on Diwali, it was like too much, you know. Acha, NEET 2018 question, that is, compound A, C8H10O is found to react with NaOI, okay, and yields a yellow precipitate. Anybody in the chat box who got their idea what is this? Yellow precipitate. NaOI, right? NaOI, yellow precipitates. Today is Diksha ma'am's day. So, yellow precipitate is CHI3. Can you tell me now, what is this reaction? Iodoform test, okay? Iodoform test. Now, compound A, this is some compound A which has 8 carbons here, is found to react with this. They are saying that A and Y are respectively. See, Y, they are saying, yields a yellow precipitate with a characteristic smell, reacts with this by reacting, wait a minute, compound A, this is found to react with Na. This is some compound A, right? That means it should have this group, CH3, C double bond O. Or it should have CH3, C OH H. So firstly, let us identify that thing. See, all are alcohols. So you need to find this thing, CH3, CHOH. CH3, CHOH. It is not here. CH2, CH2, it is also not present here. Here you have CH3, CHOH. Okay. So can you see that? CH3, CH2H, CH3, CH2H. So already we know the answer, right? CH3, CH2H. So C is the correct answer. Now let us see what they were asking about Y. Produced, now he is saying that this NaOI is produced by reacting Y with NaOH. What I told you, NaOH will be reacted with that halogen, and that halogen is I2. So answer will definitely be C, right? Okay, okay, that is C is the correct answer. Now 𝐂𝐡𝐞 has also come here, right? So this C for 𝐂𝐡𝐞 is the correct answer. Next is 2018 question. Identify the major product PQR in the following reaction. Okay. If you have too much practice now, by just seeing the question, you can predict what they are asking, right? Okay. Now, that's why practice is very important. Now, you see this. Basically, what it is going to form, anhydrous, this is Friedel-Crafts alkylation. It is going to give you this carbon ion. So, on benzene, you will have the CH2. Okay, wait a minute. This is going to, very important thing. This is going to give you a carbon ion, that is CH3, CH2, CH2 positive. Right? Now, this is a 1 degree carbon ion. So, there will be rearrangement and this will be converted to CH3, CH, CH3 positive. This is a 2 degree carbon ion. This will now react on this benzene and you will have the formation of isopropyl benzene. That means this P is basically cumene. Okay. So this P is basically cumene, that is CH, CH3 twice, CH, CH3 twice. Right? This is not P, this is not P. Now they are asking you Q plus R. What is Q? Q plus R are basically your phenol and acetone. Right? So one will be phenol, one will be acetone. Here one is phenol but the other is not acetone. Here this is phenol and this is acetone. So D will be the correct answer. D for dosa, ma'am, is the correct answer here. Okay, got it? Yes, everybody. Again, the question is from Cumene process, right? Okay. Again, the question 2018. It is from Cumene process. Next question on your screen. We have next question on your screen. Reaction of phenol with chloroform in the presence of, chloroform means CHCl3, in the presence of sodium this. They are saying the reaction of phenol. Okay. Can you see this question is repeated in previous year? Okay. This has also been asked in 2018 and 2015 as well. Introduces which of the following functional group? Which functional group it will introduce? This is Reamer-Timmer reaction. Reamer-Timmer reaction. Right? Reamer-Timmer reaction, the electrophile is dichlorocarbene. So what is the answer here? This phenol will have the attachment of CHO group. So answer will be C is the correct answer. Right? C is the correct answer. No, C is the correct answer. They are asking you, introduces which of the following functional group is introduced? Which functional group is introduced? CHO, right? Aldehyde group is this, salicyl aldehyde is formed. CHO group is introduced here, right? So C is the correct answer. Next we have NEET 2015 question. Which of the following reaction can be used for preparation of alkyl halides? For the preparation of alkyl halides, which reaction can we use? Okay, which reaction we can use? If you have HCl and ZnSCl2, this will be replaced by, definitely this is possible. This will be CH3, CH2 and Cl. This is possible. With simple Cl, with simple HCl, it's not possible. See, Lucas reagent, right? If it is 2 degree or it is 1 degree, then it requires anhydrous ZnCl2. But if it is 3 degree, like this is, we know now with 3 degree it is very reactive. Do you remember Lucas test? With 3 degree it is very, very reactive, right? With 3 degree it is very reactive. So now with 3 degree, that is the reason it will be able to give the answer with 3 degree as well. So answer will be CH3 thrice CCl. With 3 degree, no anhydrous ZnCl2 required, right? So first is also correct, we can prepare. Third is also correct. Second is also, we have anhydrous Cl2. So first, third and fourth. That means D is the correct answer, right? Okay, so D will be the correct answer. Next we have the reaction. This is the reaction, 2016 question. The reaction, you have to give it methyl, can be classified as, okay. Can you see this thing here? This is CH3I, that means basically this is RX. This is RONA. What is the answer for this? What should be the name of the naming reaction? Hai na? Good question, na? RONA RX. Now, dehydration, Williamson alcohol synthesis reaction, there is nothing as such Williamson alcohol synthesis. The one who will take this has no idea about chemistry, right? The person who will say B, he will have no idea about chemistry because there is no such reaction, right? This is Williamson synthesis reaction of ether formation, right? Very good. Ether synthesis we have here, right? Next is 2015 question. The reaction is called, again from Williamson synthesis reaction. Do you remember this? I told you that this is O, this Na and this Cl will eliminate and you will have the formation of CH3. This is CH3, right? Okay, what they are asking then? This they have given. Acha, they are asking the name only. What is the name, guys? Williamson synthesis reaction. Now, to confuse you, they have given continuous esterification process, right? So, just to confuse you. Okay, so the answer is Williamson synthesis reaction. Okay, so C is the correct answer. Oops. Chalo, now to you have seen the answer only, right? Which phenol is treated with CHCl3NaOH? Again, Reimer-Tiemer reaction. They are, see, 2002 question which is being repeated in 2017 also, right? So, which phenol is treated with this Reimer-Tiemer reaction basically they are talking about, and here you have the formation of salicyl aldehyde. Have you seen this reaction was asked in I think 2015 as well. This, right? The same question was asked in a different form in 2015, right? So this is how the repetition occurs, okay? That's why previous year questions are important, but you should know that how to use them also. Which of the following is correct? On reduction, they are saying on reduction, any aldehyde gives secondary alcohol. Reaction of vegetable oil, basically alkene they are talking about, with H2O give glycerine. Alcoholic iodine with NaOH give iodoform. This so we can see which is correct. Alcoholic iodine with NaOH, it gives iodoform, right? Okay. Sucrose on reaction with NaCl give inert sugar. Reaction with this on reduction, aldehyde gives secondary alcohol. Aldehyde will not give secondary alcohol, right? So answer C is the correct answer, okay? So basically iodoform test they are asking you, that is formed by alcoholic iodine with NaOH, right? Okay. Now, next is, among the following sets of reactants, which one produces anisole? For that, you need to know what is anisole. Okay, anisole is OCH3. This is anisole. Now, how anisole is formed from these reactions? See, first is CH3CHO with RMgX. If you have CH3CHO, you don't have any benzene, then how can you make this thing? So definitely not possible. Here you have benzene, here also you have benzene, here also you have benzene, right? Here you have NaOH and CH3I. Acha, this is Williamson synthesis reaction. Again, they are asking Williamson synthesis reaction only. Why? Because this is alcohol. In presence of NaOH, it will be converted to C6H5. C6H5 means benzene. In presence of NaOH, it will be converted to, rather than OH, it will be converted to ONa. Then you have CH3I also. Now what will happen? This NaI will be eliminated, right? And it will form a ether, right? So answer is B is the correct answer, right? Very good, very good. Next we have identify Z in the sequence. You have to identify Z in the sequence. This reaction you have, right? Okay. Again, I think it's a question of Williamson synthesis, ether formation only, right? Told you this is their favorite reaction, right? They frequently ask question on Williamson synthesis. Very easy questions are asked on that, right? So firstly, though, you need to know this reaction. So first is CH3, CH2, CH. Can you see? They ask the naming reaction with some very important reaction, right? Here, this is a very, very important reaction. If you have a peroxide, HBr in presence of peroxide, it will show anti-Markovnikov rule. Anti-Markovnikov. Do you remember that? Anti-Markovnikov. So here it will be CH3, CH2. Anti-Markovnikov means negative part means this is positive, this is negative. Negative part will be attached to more number of hydrogens. So it is CH2CH, CH2, here you have Br and here you have hydrogen. Okay, so this basically it will become CH2, right? So that will become your answer. Not the answer, but this is Y, right? This is Y. This basically is Y. Now, after this they are saying you are adding C2H5Br. No, not Br, C2H5ONa. Now it is Williamson synthesis because you have alkyl halide and you have alkoxide, right? So now what will happen? CH3, what will happen here? CH3, CH2, 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 then O, C2H5, right? Okay. CH3, how many times CH2? We have 3 times. So CH3, CH2 3 times, then O, then C2, CH3. So answer is A is the correct answer, right? A will become the correct answer, okay? Very good. A will become the correct answer, okay? A will be the correct answer. Next. Are you all able to answer these? Is there any doubt till now? Guys? 2020 they have asked the question, among the following ether, which one will produce methyl alcohol on treatment with hot concentrated HI? Methyl alcohol. This is actually opposite. This is not supposed to be a naming reaction, right? But now Chalo, no issues. Now methyl alcohol. From where you can get the methyl alcohol? Let's not do this today, right? Because this is not included in the naming reaction. So if you want to do this, you can. So basically what will happen? This will be H positive, I negative, right? It will break this or this bond and you will get the formation here, right? Now always remember, the same way alkyl halide wants to be primary, right? Okay. So where you will get, which is falling ether, which one will produce methyl alcohol? Methyl alcohol. Which will produce methyl alcohol? I think A will be the correct answer. A is the correct answer, right? Okay, those who understand this, then good for you. But if you're not able to understand this, then this is not included in the naming reaction. I think by mistake I have picked it here, right? So basically what we want to do here, we want to make CH3OH here, right? So it is a reverse of Williamson synthesis reaction. So things will be reversed here, There we used alkyl halide, which is primary. Here we will form that alkyl halide, which is tertiary. So here this bond will break, here hydrogen will attach, and here iodine will attach. Alkyl halide will be tertiary and alcohol is primary, secondary, tertiary, whatever it can be. Right? Okay? Right? So answer is A. Next is, now let's do these reactions, these questions. Clemmensen reduction of ketone is carried out in the presence of which of the following? Just ignore the number there, right? Clemmensen reduction of ketone is carried out in presence of which of the following? Clemmensen reduction is carried out in which? That is zinc amalgam with HCl, that is B is the correct answer, right? B is the correct answer. This is asked in NEET 2011. Right, next we have benzoic acid give benzene on heating. Now they are saying benzoic acid. These are questions which are repeated in some of the competitive exam which can be asked in your NEET. Okay, so benzoic acid, because the question like from aldehyde, ketones, carboxylic acids, they ask like most of the naming reactions are asked. That's why I picked out these questions. Okay, so benzoic acid give benzene on being heated with X. Okay, benzoic acid, it will give benzene. It will give benzene on being heated with some X, right? Can you see what exactly? Can you see this is basically soda lime decarboxylation? Because this will be taken out and here you will have the attachment of hydrogen. Basically, this is your benzene. So, soda lime is definitely the correct. This is wrong. Now, they are saying it heated with X and phenol gives benzene on being treated with Y. And phenol is going to give you benzene on treating with which thing? Anybody? Today we have not learned this reaction, but this is a very, very simple reaction. With the zinc dust, it is going to give you benzene. So answer will be D is the correct answer. Okay, very good, shabash. Next is, which one of the following is not formed when acetone reacts with 2-pentanone in the presence of dilute? What is this? NEET 2022 question. Very, very important, a very lengthy question this is, right? Okay, very, very lengthy question it is, right? So, do you want me to solve this or do you want to do it yourself, right? Okay, everybody, this is what motivation only, na? When I am teaching you, I am motivating you only, right? Now, basically, this is aldol, cross aldol. This is a question of cross aldol. Do you want to take it to your homework? Because so that I can solve it in the next day, like in next lecture, we can solve it, right? Because see, I can solve this question now, but I have already given you the trick to solve it, right? You have two things. One is acetone, that is CH3, C double bond O. Firstly, acetone will react with itself. Then 2-pentanone. 2-pentanone means 1, 2, 3, 4, 5, right? Second position you have this is CH3, CH2, CH2, CH3. Then, first I'll just give you the hint. Try to solve it yourself. I'll just erase the answer here. What is the correct answer? I'll just erase that here, right? I'll also erase the... I have also erased the answer as well as the hint here for the answer, right? So, I'll not teach this today. Today, though, I will not teach this, right? Because I have already told you how to solve it. I want you to practice it yourself. See, what's the use I am doing it only on this, like on this board I am doing this? Because this question is useful, that will benefit you only if you do it yourself, right? I'll give you the hint. Firstly, this molecule will react with itself and give you one aldol product. Then this molecule will react with itself and give you one aldol product. then this carbonyl and this alpha hydrogen, then this carbonyl and this alpha hydrogen. Now remember one thing, here you have two alphas, right? Here you have two alphas. So when this carbonyl is working as a carbonyl, this carbonyl is converted into OH, and this alpha is getting converted into, then you will firstly use this alpha, then you will use this alpha. So total 5 products will be formed here. Okay, total 5 products will be formed. Okay, so this is your homework. Take a screenshot of this one. Take a screenshot of this one, right? I'll also have this slide in the end only, right? Wait a minute. You'll think, ma'am, how many questions you're going to teach today, ma'am? I'll stop when you will say, ma'am, please stop. Okay? Don't worry. I'll stop only when you will say, ma'am, we are tired. Please, ma'am, now leave us, ma'am. We are tired of you, ma'am. Please leave us. Okay? Then I'll stop. Right? But we have a lot of questions. If you want to practice today only, I'll do. Otherwise, in some other section, in some other session, we can practice. Reaction between benzaldehyde and acetophenone in presence of dilute NaOH is known as. Reaction between benzaldehyde is what? Benzaldehyde is this one. And acetophenone. What is acetophenone? Acetophenone is basically COCH3, right? Reaction between benzaldehyde and acetophenone in presence of dilute this is going to give us what kind of reaction? See, this does not have any alpha hydrogen. No alpha hydrogen. But alpha hydrogen is present here. It has alpha hydrogen. So it will give you aldol condensation, right? So answer cross aldol. Answer should be aldol, by the way, because cross aldol is not possible because it is having only one alpha hydrogen. So according to me, answer should be aldol, right? According to me, answer should be aldol. Okay? Because cross aldol, 2 products you have, na? Cross aldol it will be. Cross aldol only because you have 2 products, right? You have 2 products. Cannizzaro it will not be because one has this alpha hydrogen, right? This has alpha carbon and alpha hydrogen, right? Okay. So answer will be cross aldol. Yes. Now next is the catalyst used in Rosenmund reduction. Rosenmund. Okay, what was the catalyst? Right. So answer is B. Very good. Next, benzaldehyde can be prepared by oxidation of toluene. Okay. They are saying that you have to prepare with the oxidation. Shabash, everybody. Very important reaction. This is toluene. You have to prepare benzaldehyde. What is the name of the reaction and what is the reagent that you will use? Right? Okay? Yes. B for the previous question. Very good. Shabash. Now what about this one? B here. Are you sure? Are you sure? Guys, I'll give you one hint. Ithard's reaction it is. Ithard's reaction. Ithard's reaction. See, if you use K2Cr2O7, this will be converted to directly benzoic acid because it's a very strong oxidizing agent. So, here you will have chromyl chloride, CrO2Cl2, chromyl chloride. So, answer is CrO2Cl2, that is Ithard's reaction is the correct answer. Otherwise, with acidic KMnO4, right, or with acidic KMnO4 or this, it will be converted to benzoic acid. So then the answer will become benzoic acid, right? But to have benzaldehyde, you need to use chromyl chloride here. C for chutney. Okay. We have seen the answer only. What is the product of the following reaction? So this is called basically Stephen's reduction, right? Here, this CN will be converted to CH2 NH2 because C triple bond N, 2 pi bonds will break and you will have NH2 here, CH2 here, right? So answer will be CH2 NH2, right? Acha, after hydrolysis also, we have done hydrolysis also, no? Wait a minute. Arey, nahi, this is SnCl2, right? So sorry, that was Mendel's reduction, right? So it is C, 2 bonds will break here, right? So only one bond will break. This is NH and this is this. So imine will be formed here. After this, after the hydrolysis, this whole thing will be converted to double bond O. So it will be CHO. That means benzaldehyde will be formed, right? Okay. So answer is this. Answer is benzaldehyde is formed. Next question is acetone reacts with iodine to form which iodoform in the presence of what? See, acetone definitely it will give you iodoform test because it is having this compound, this group it is having. Now acetone will give iodoform if it has NaOH plus I2, because then it will become NaOI, then the answer will be correct. So answer is NaOH. B is the correct answer. Okay, B is the correct answer. So answer B is the correct answer. Now this is called aldol condensation due to. Now they are saying that CHO, CH3, CH3, CH3. This does not go under aldol condensation reason. 3 electrons donating absence of alpha. See, simply yaar, what is the condition for aldol condensation? It should have alpha hydrogen. It does not have any alpha hydrogen. So absence of alpha hydrogen in the molecule. Others, so you don't even have to see, right? Others, so you don't even have to see, right? Okay. Okay. Next is iodoform. Shivam, you really want to be a doctor, right? A doctor, you know the internships of doctors, right? It is 56 hours, 36 hours, 2 days continuously without any sleep. So if you have that dream, 4 hours is nothing in front of that, right? So it's not only about NEET exam that you are getting prepared for, it's for a long journey that you are going to have after that, right? Okay, so if you want to be successful, question B, correct or wrong? Rathi, I'll tell you in the next lecture, okay? You just write this in the comment section. I'll tell you in the next lecture, okay? Yes? Iodoform test is not given by. Now, let us draw all these things. Pentane 2-on, 1, 2, 3, 4, 5. Pentane 2-on means this thing, right? Then you have ethanol, 1, 2, CH2, OH. This is CH3. So, basically, this is CHOH. Definitely, it will also give. Ethanol means CH3, COH, right? Pentane 3-on means 1, 2, 3, 4, 5. Third position, you have this. Now, guys, tell me. Very simple, yeah, very, very simple. If you see this here, it is having CH3CO. It is having CH3CHOH. It is having CH3CO. So these three are to definitely giving us the answer. But 3-pentanone, it is not having CH3CO. So D will be the correct answer. Right? D is going to be the correct answer then. Next is phenyl methyl ketone can be converted into ethyl benzene. What is this? Phenyl methyl ketone. Now this happens after 4 hours of teaching, huh? So phenyl methyl ketone. Phenyl methyl ketone is nothing but acetophenone only. Okay? So phenyl methyl ketone, that means this thing they are talking about, acetophenone, can be converted into ethyl benzene. They are saying it can be converted to ethyl benzene. Then students say that, ma'am, IUPAC naming is not important, ma'am. Beta, if you don't know how to draw the structures, how you will be able to answer it, right? So Phenyl methyl ketone can be converted to ethyl benzene. That means this thing. CH2, CH3. Can you see the answer? Simple. Right, by which of the following? This CO is converted to CH2. Like CO is converted to CH2. Yes, everybody. Reduction we have done, but the reduction I'll just name it. Right, I'll just name it. That is Clemenzin or Wolff-Kishner reduction. If you see the condition for Clemenzin or Wolff-Kishner, that is the correct answer. Right? Good night, ma'am. Sorry, my data is over. Don't worry. Okay, Tanuja, see you in the next class. Okay, take care. Good night. Okay, now you have CO and CH2. Now tell me that basically Wolff-Kishner or Clemenzin. I can see the condition for Clemenzin. So answer is B is the correct answer. Okay, or it can also be Wolff-Kishner. Wolff-Kishner is NH2 in presence of ethylene glycol and KOH, right? So that can also be the right answer. But here that is not in the option, right? Aldehyde and ketones are distinguished by which of the following test? Aldehydes and ketones. Aldehydes and ketones are distinguished by Lucas test, Tollens test, KMnO4 solution, and none of these. Lucas test is not for this. Lucas test is for 1 degree, 2 degree, 3 degree alcohol. Tollens test is for distinguished test for aldehyde and ketone. KMnO4, that is Birch's test, is for which thing, guys? That is for unsaturation. That is for unsaturation. Test for unsaturation, right? So answer B is the correct answer. The most appropriate reagent to distinguish between acetaldehyde and formaldehyde. Okay, now this is a good question, okay? So this is HC double bond OH and this is acetaldehyde, CH3C double bond. Now this is a good question, reason being I forgot to told you, right? I forgot to told you when we were doing that reaction, okay? So that's why this becomes important because mostly students don't know this. So now Tollens test. Wait a minute. This is distinguished between acetaldehyde and formaldehyde, no? Huh. No, this is not important. Okay. Just write down one thing when we were doing Tollens reagent, that formic acid gives Tollens. I've got confused between formaldehyde and formic acid. Just write one more thing because now I remember that, right? Whenever I remember something, just write it down. I'm also writing it here. Tollens. This is not related to this question, okay? So Tollens, or I'll just see where was Tollens, I'll write it there only, right? I'll write it there only. Now for this one, we know that CH3CO, this is given by Iodoform test. So iodine in presence of base, right? It will give this, but it will not give this. So answer will be D is the correct answer, right? Now, I don't know where we have done Tollens test. I think here it was. So here also you can write one more thing, that formic acid also gives this test. Okay, that is HCOOH. Okay, just write down, all the other acids will not, but formic acid will give this test. Acha, where we were. Next question is, which one give positive iodoform test? Again, this is CH3, CH2, so this is definitely giving. Why? Because this is CH3, CHOH, right? So we need this thing. So it is giving positive test, right? This does not have that thing. CH3, C double bond O, this is the main criteria. Then if you reduce this thing, it will be converted to OH here and this is H. So if you anywhere you find this alcohol, that will give positive test. That is only in D. So answer will be D is the correct answer. I don't know why I always look for, I don't even see the other options. I don't know why, how I always firstly see the right answer only. I wish you also do the same thing in exam. Okay. Next is Tollens reagent is ammonical CaSO4, ammonical AgNO3, alkaline solution of complex copper nitrate, none of these. That is ammonical AgNO3 solution, right? So B is the correct answer. Two compounds, benzyl alcohol and benzoic acid, are formed from this compound. When this compound is heated in presence of concentrated, definitely they are talking about Clemmensen reduction. Not Clemmensen, sorry. Cannizzaro reaction. Cannizzaro reaction. How benzyl alcohol and benzoic acid are formed. Alcohol and acid are formed from this compound. Benzyl alcohol is this one. This also we have done today. Right? Basically in Cannizzaro reaction, if you have this thing, if you have CHO, now from here, because it does not have any alpha hydrogen, from this you will have the formation of benzyl alcohol and benzoic acid salt. Right? Disproportionation reaction. So answer will be benzaldehyde. From benzaldehyde you will have the answer. Right? Okay. Yeah, I had my dinner. Am I looking tired? Am I looking? Yeah, my legs are totally gone right now. Abhi to my legs have given up. They're like, okay, please, we want to sit. But I will complete it. Don't worry about that. In the following reaction, okay, can you see what is this reaction? Anybody in the chat box? Br2 phosphorus. Br2 phosphorus. Bure chor. No, not bure chor. This was on the alpha hydrogen. This is HVZ reaction. Helvohard-Zielinski reaction. On alpha hydrogen, you have the replacement of hydrogen with the halogen. HVZ reaction this is. HVZ. Guys, you should have this much practice so that you can identify by just looking at the question that what is this. Right? Now, excess of NH3. First is RCH, is present here, okay, not here, only here and here. So, A and C cannot be the correct answer. After that, you are adding excess of NH3. That means this will be converted to double bond NH2, right? So, here answer will be RCH, right? CHCOO, wait a minute, CH2CO NH2. I think the answer should be D. Wait a minute, let's check. Why? CNH2COOH. COOH, excess of NH3. Wait a minute, when we have NH3, then halogen is replaced. Wait a minute, you have OH here. You have excess of NH3. CH2, CH. First, so Br will be replaced, that is so true. Right? Achha, there is only one option where it is happening, no? So, this will be replaced by NH2 only. Right? Okay. Yes. Because this to cannot happen, it cannot be reduced, right? It cannot be reduced. I told you B only, no? Or I told you D is the correct answer. I don't remember, right? So this cannot be reduced by excess of NH3, right? So that means NH2 will be replaced, Br will be replaced by NH2, right? Okay. Then they have given us the option of COH only. So that's why B will be the correct answer, right? Okay. Okay. So B will be the correct answer. Next is an organic compound A. You have an organic compound A upon reaction with NH3 gives B. Okay. On heating B gives C. C in presence of KOH reacts with Br2 to give this thing. KOH and Br2. Can you identify this reaction? Br2 in presence of phosphorus, that was giving us HVZ. But Br2 in presence of base is giving us which thing? Br2 in presence of base, that is giving us Hofmann bromamide degradation, right? So answer, I think C will be CH3, CH2 amide only, right? Now this will be the C, this will be C. On heating B gives C. On heating B you are getting this. And they are asking you A's. See, an organic compound of A upon heating with NH3 gives B. So on heating with NH3, it is giving B. B on heating B gives C. So on heating B, you get C. Okay, organic compound A on reaction with NH3. I think my brain has stopped working. An organic compound A on reaction with this, and why I am not able to process this? Definitely this is not the correct answer. CH3, 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 CH2, CH2, COH, right? So here you will have this thing firstly though. CH3COH, right? This upon reacting with NH3, it is going to give you CH3CH2CO NH2, right? On heating B gives C. C in presence of this, okay. Acha, okay, got it. Why they have given us 2 steps. CH3, this on reaction with NH3 will give us CH3CH2CO. This is basically NH4. This will be ONH4, CONH4, right? This will be basically something like that, right? OH will be replaced by this NH4 here, right? Then it will be heated, it will become NH2. Now this is your C. Now after reacting with Br2 in presence of KOH, this will be eliminated. It will give us CH3, CH2, NH2. है ना? So I think D will be the correct answer. Only that is becoming like CH3, CH2, NH2. है ना? Propanoic acid. Yes, propanoic acid. D is the correct answer. Yeah, I think I am now, right now, so I am almost dead. Addition of waters. Let us see how many questions we are left with. Very few questions. We can do that. We can do that together, guys. Addition of water. They are saying addition of water to alkynes occurs in acidic medium in presence of Hg. They are talking about Kirchhoff's reaction as a catalyst. Which of the following products will be formed on addition of water to but1-ine? But1-ine means but 1, 2, 3, 4. 1-ine means this H and this is C. This is not. This is CH2. So when a pi bond will break, you will have positive here, negative here. So to this negative, you will add this H2, and to this positive, right? To this positive, you will have OH, right? After this, it will be replaced as this double bond will shift here. This double bond will shift here, right? This double bond will shift here, and here you will have only oxygen, and one H will be shifted here. So this is CH3, CH2, CO, CH3. CH3, CH2, CO, CH3, that is B will be the correct answer. Okay? B will be the Hofmann bromamide degradation. Yes, Hofmann bromamide degradation. This is not Hofmann bromamide degradation. This is Kirchhoff. This is Kirchhoff's. Okay. Next we have the reagent which does not react with both acetone and benzaldehyde. Which will not react with both acetone. Acetone is CH3. C double bond O, CHE, that means it should not react with ketone, and it should also not react with benzaldehyde. That means aromatic aldehydes it should not react with. So guys, Fehling reagent, no, it is very selective towards aliphatic. It only shows answer with aliphatic aldehydes, not with ketones. Tollens will show with both aliphatic and aromatic aldehydes. But Fehling will only give test for aliphatic. So it will not give positive test for aromatic or for ketone. So answer will be C is the correct answer. Right? Now again that is the same question that we are getting. Now they are asking that structure A and type of isomerism present in. This is again Kirchhoff reaction only. Structure A. See what will happen to this? One pi bond will break here. One pi bond will break here. Positive will come to this side, so that's why it will be OH here and one hydrogen here. So it will be prop 1 in 2-ol, right? Prop 1 in 2-ol. This. And answer will be tautomerism. Tautomerism is here and here. Prop 1 in 2-ol is here. So D will be the correct answer. Okay? D will be the correct answer. Right? D will be the correct answer because prop 1 in 2-ol and this thing is, this isomerization is tautomerism. Right? Okay? Which of the following reaction will not result in the formation of carbon-carbon bonds? Will not result. So in a Riemann-Timmer reaction, you have the formation of carbon-carbon bonds. In Cannizzaro also, in Cannizzaro basically, in Cannizzaro there is no carbon-carbon bond. Because in Cannizzaro what you have? For example, I am talking about this thing. This CHO is converted to CH2OH. And this CHO is converted to COONA. So there is no formation of new carbon and carbon bonds. Here you have new formation. Here you have new RR formation. Here also you have R. Here basically you have, it was phenol. And now you have new CHO group here. So new carbon-carbon bond is formed. In Friedel-Crafts acylation also you have this benzene. And over this benzene you have CH3 attachment. New bond is formed. So answer will be B. Cannizzaro reaction will not have new carbon-carbon bonds formation. Right? Okay. Next is this question. Next is this question, everybody. I think last chapter, now last chapter, that is amine. We are only left with 4 or 5 questions now. We are just on the last chapter now, that is amines. Let us finish that off, okay? Identify the compound that will react with 𝐻INSBERG reagent to give a solid which dissolves in alkali. 𝐻INSBERG reagent, very good question it is. Which is dissolved in alkali, means 1 degree amine you need to identify. See, this is not 1 degree. This is definitely not 1 degree. It is 3 degree. It is 2 degree. It is 3 degree. So it's a very good question. Okay. This is 2 degree. This is 3 degree. This, my friends, this is 1 degree. Okay. So here C will be the correct answer. It's a compound which react with this to give a solid which is dissolved in alkali. So soluble in alkali is 1 degree amine. So answer will be C, SEE, C. So C is the correct answer. Right? Okay. Then you have next is NEET 2017 question. Which of the following reaction is appropriate for converting acetamide? Acetamide means this thing, right? Okay. Acetamide to methanamine. Simple. Methanamine means this thing. Which reaction? This thing will be eliminated. That means which reaction, guys? Everybody. Which reaction? Very simple question. Which reaction is this? This will be eliminated. I'm waiting for your answers in the comment section. Yes. What will be the correct answer, everybody? What will be the correct answer? Hofmann hypobromamide, Stefan, Gabriel phthalimide, carbylamine. These are the 4 important reactions of amines. Right answer is definitely A is the correct answer. That means Hofmann bromamide degradation. Right? Okay. Next we have which of the following amines? Now they are saying which of the following amines will give carbylamine test. Carbylamine test is only given by primary amines, whether it's aromatic or aliphatic. Right? Whether it's aromatic or aliphatic, this is definitely 2 degree amine. This is also 2 degree amine. This is 3 degree amine. This is the only 1 degree amine you have. So answer is again A is the correct answer. This is NEET 2020. Such simple question they are asking you. Right? Are you getting that motivation, that confidence now? Right? Okay, are you getting that motivation now? Getting that confidence now? A for aims, right? A is the correct answer, right? Now, I think this is your last only. Let me see. I think maybe last or last second question it is. 2019. The amine that reacts with Ginzburg reagent. They are saying that amine which reacts with Ginzburg reagent to give alkali insoluble. Can you tell me alkali insoluble? Alkali insoluble means 2 degree product, 2 degree amine. This is 2 degree amine because nitrogen is connected to 2 alkyl chains, right, and 1 nitrogen. Nitrogen is connected to only 1 alkyl chain, so it is primary. Nitrogen is connected to only 1 alkyl chain, so it is again primary. Nitrogen is connected to 3 alkyl chains, so it is tertiary. So answer will be 2 degree. I can't see 2 degree. There I have seen 2 degree. That means A will be the correct answer. Right? Okay. Very good. A will be the correct answer. Let us see. Given below, let us see who can answer this. Okay, I'll see who will answer this question. Thank you, Ram. Thank you. Okay. Given below are the 2 statements, 2022 question it is. Okay, so latest, just 2 years back, this question has been asked. Let us see if you can answer this or not. Right? Okay, so this I have not taught you today. Right? I just want to see if you remember other things or not. Okay, this is basically I want to see whether you need one more session on important reactions which don't have as such a name, right? But they are important, basically the important reagents. Okay, so let us see. Primary aliphatic amines. Primary aliphatic amines means CH3 like this, NH2. React with HNO2, right? Give unstable diazonium salt, that is true. It will react with this and it will give to N2Cl. But it is so unstable that without anything, it will be converted to OH. You just need to add water here. It will easily be converted to CH3OH. So it is very unstable. But primary aromatic means like this. Primary aromatic means like this. It's a very, very important question, okay? Primary aromatic amines react with the same, that is HN. What is this? Diazotization we are doing. They can also write NaNO2 and HCl. They can also write HNO2, right? So NaNO2 or HCl or HNO2 to form diazonium salt. Okay, diazonium salt it is forming. What is diazonium salt? This is diazonium salt, right? Diazonium salt which are stable even at 300 Kelvin. 300 Kelvin means which are stable even above 300 Kelvin, right? Now this is not stable at 300 Kelvin, guys. Why? Because when we were doing this reaction, we were saying that 0 to 5 degrees Celsius. That means 273 Kelvin, add 5 into it. That will be 273, 74, 75, 76, 78. 273 to 278 Kelvin, this product is stable. After this product is not stable. At 300 Kelvin, this product is not stable, right? 0 to 5 degrees Celsius, it is stable, right? So here, we can say that this statement is false. This statement was true. So statement first is correct, but second is incorrect. So C is the correct answer, okay? In hurry, usually students are like, okay ma'am, yes, they are right ma'am, they are forming a compound, ma'am, disonium salt. But see the temperature, right? See the temperature. CiC3. C, I say 3. C. Acha, this is your homework. Now everyone take the screenshot of this homework. Everybody take the screenshot of this homework. I want to see your homework in the comment section, right? You will write the IUPAC name. Okay, not IUPAC name, just give me the answer. Just give me the correct answer in the comment section, whether A, B, C, D, which is the correct answer. Okay, in the comment section, I will see your comments and I'll see whether you are answering it, because see how much hard work I have done for you. I have prepared handwritten notes, right? I have literally, before this class, I have worked for like 4 to 5 hours, collecting all the naming reactions, collecting all the questions based on the naming reaction from different chapters, right? It takes a lot of hard work to do that, right? I could have just come here and taught you, like, okay, just naming reaction will do. But I am doing previous year questions as well, right? Because I know how crucial this time is, because we are just few months away from NEET. And very easily these few months will pass, just like last 6 months has passed, right? So that is a, request to all of you, don't waste even a single minute, right? Why I am not here chit-chatting or gossiping or maybe, fun and all doing here. Like, I focus on that, okay, my students are here and I want to teach them, right? Not waste their time here, right? Reason is because I value your time. So you should also start valuing your time, right? It's December and May is just next corner, okay? So it's a very crucial time, and don't waste in it unnecessary things, right? Just focus on practice, focus on revision, focus on memorizing the formulas, focus on practicing the questions on those formulas, practicing the naming reaction questions. That's the way I taught you today, right? Firstly, we went through the theory part, right? All the naming reaction distinguished tests firstly we did. After that, we saw that what kind of questions they ask you, right? So this is how it will be very easy for you to remember things, right? Okay? Yes. Thank you, Soumya. Thank you, Ram. Okay. Thank you, Nikhil. Till now, though, guys, I am not getting the time, and I really feel you should also not get time to watch movies, okay? Movies you can watch after May exam, after your 5th of May, right? But before that, focus on this. First class, bahut achhi. Thank you so much, Ithar. Thank you so much. Thank you so much, Abhishek. Yes, dedication is very important, because when you are teaching future doctors, then if the teacher is not dedicated, then how the students will be dedicated, right? So these students are only going to, be the future of our next generation, right? They are going to be the future doctors who are going to take care of all the people out there. I really hope you become a really good doctor, so that this dedication, this hard work that we are putting for you, that will be valuable not only to you, also the society, right? Okay then, bacha. Bye. Take care. See you all in the next class. Now I'll be waiting for your comments in the comment section related to this question, whether A, B, C, D is the correct answer, right? Okay? Yes. Okay, thank you so much, beta. Bye bye. And also share this session on your WhatsApp group. Don't be confused, right? Don't be confused. If you will not share, right? See, if you will not share, then tell me one thing, that how I will be able to reach to more students, how I will be able to make sure that the student who need this kind of content, right, is able to get that, right? Don't be selfish, right? Suppose I behave like a selfish person, then what will happen? You will also not get good content, right? So if I am not behaving like a selfish person, you should also not behave like that, right? You should also spread the knowledge, share this on your WhatsApp, share this on the Instagram. My handle is Diksha__Kaushal, right? That is my Instagram handle. You can talk to me over there. And also you can talk to me on Telegram channel. The Telegram channel is, I'm writing it here. That is t.me/Diksha Kaushal Chemistry, right? There you will see my Josh Talk DP, and there you will see Diksha Kaushal official chemistry, right? Okay, so that's my Telegram handle. You can join there and you will get definitely all the good quality content there. Okay, yes, now the notes will be available on my Telegram channel as well as Vedantu NEET English. Okay then, bye bye, take care, see you all, and good night. Bye bye.